Stacklok. Stacklok is a fast-growing company in this space. Our CEO and CTO are two of the co-creators of Kubernetes, and we're helping enterprises build and run AI agents and MCP on their Kubernetes infrastructure. Today's event is also brought to you by Databricks, who are obviously a force in all things data analytics and AI. We were running an event here in our Seattle backyard late last year on MCP. We had about 150 developers join us in person. We ran a bunch of great sessions, dug into MCP in detail, and afterwards, our friends from Databricks came up to us and said, "That was great, let's do that again, but let's try and do it bigger." And so here we are. Today's virtual event has got a lot planned. Let me walk through it for you. We've got 9 sessions. We've got 9 great speakers, and each of them is going to dig into a specific aspect of the Model Context Protocol. And it just so happens that those 9 sessions divide up neatly into thirds. The first third of the day is going to be focused on getting started with MCP. How do you build a registry? What's the difference between skills and MCP servers? The middle third is going to be about optimizing MCP. What can you build? How can you include it in part of your agentic workflows? How do you make sure that you're selecting the right tools and avoiding context bloat? And the final third of the day is going to be more focused on enterprise use cases and how you're going to deal with things like identity and authentication, security and scale. So we're going to cover a lot of material, and we're really excited that you can join us because this is a live stream and there are some experts floating around in the chat. If you've got questions, if you've got ideas, you should use that space to ask. We'll do our best to help each other along over the course of the event. And with that, let's get started. Our first session of the day comes from someone who's been in the MCP space for a long time. Tadas is a creator of Pulse MCP. If you are not subscribed to the Pulse MCP newsletter, I suggest that you go find that now and sign up. It's something to look forward to every Wednesday. Tadas is also one of the maintainers of the official MCP registry, so he's deeply embedded in the community and the ecosystem, and it makes sense to kick off with his talk, focusing on the difference between open loops, where a human is involved and you get some incremental productivity from an agent, versus closed loops, where an agent has everything it needs to work autonomously, including access to MCP servers. So Tadas is going to distinguish those two for us, and I'm going to hand things over for him to get us started. Thanks so much.
Hey everybody, thanks for joining me today. I am going to talk about closing the loop with you all. So this is one of my favorite use cases for MCP in the world of agentic engineering. So my name is Tadas, I'm from Pulse MCP, and I am excited to talk to you about this. This is mostly going to be a talk for software engineers. So it's not really for like non-technical folks vibe coding, so mostly for the practice of software engineering. But you know, if you're not technical, you can still probably get some insights out of this as well that you can translate over. But my audience here is definitely software engineers. So who am I? I spend most of my time doing 3 things. So I'm on the MCP steering committee. I am a maintainer of the MCP registry and a maintainer of the contributor community on GitHub and Discord. Another chunk of my time goes into, most of the rest of my time goes into Pulse MCP, which is partially a weekly newsletter and a MCP server catalog used for discovering MCP servers across the ecosystem. And lately, as part of Pulse MCP, I've been spending a lot of time doing coaching on agentic engineering. So I go in with teams and I help engineering orgs level up with a variety of agentic workflows and tooling. So that's what I spend most of my time doing. And on closing the agentic loop, this is where most people that I work with start at. A lot of engineers use coding agents like this, where it is more like a pair programmer relationship than a relationship with an agent, where you send a prompt, you review a minute or two later, you review the output, you maybe you go and you take a stack trace, you paste it back to the agent, then you prompt again, you repeat. We've all, at some point in our AI-enabled journeys have had a workflow like this, and most people are still here today. Most engineers I work with start here for sure. And it's still, this is productive, right? Like this is the first step in getting some sort of value out of using AI. And I think from teams I've worked with who are trying to like more objectively measure this does result in some sort of like 10 to 30% sort of productivity ramp up. And so it helps. But where you can really ramp up the amount of value you can potentially get out of AI is when it looks a lot more like this. This is where a human is delegating to an agent in a loop, where it's performing a sequence, like, and we'll talk about this more in the slides to come, of like acting, observing, verifying, and importantly, the human is just giving one prompt at the beginning, and then a whole lot of other stuff happens. There's obvious drawbacks or guns with this approach, where this is how vibe coding works, right? And that's not what we're here. We're not here to talk about vibe coding here today. We're talking about software engineering. And so what I want to get out of this what I want you to get out of this talk today is how to do this in a way that basically breaks down the craft of software engineering into a workflow where this is a productive way to break things down, and where MCP fits into that. At the end of the day, where you get is from those like 1 to 2 minute turns that the like prepare programmer approach to agentic engineering, to engineering with AI goes, is you get over to like 10 to 20 to 30, maybe even hour-long turns with agents, with coding agents at your fingertips. So that's where we want to get. What I'm going to cover here in the next 15 minutes or so is, number one, what do I mean when I keep saying agentic loop? What does that mean? Number two, what does closing the loop mean? And then I'm going to jump right into a couple very specific demos that hopefully, that are, they're somewhat contrived, but like as practical as I can get here in 10 minutes. And we'll see what I mean in action. And before we leave here, I'll give you some concrete next steps you can do to start actually putting this into practice in your day-to-day software engineering work. So number one, what is an agentic loop? Courtesy of Simon Willison, we have a definition of agent, and that's really tools running on a loop to achieve a goal. And I personally extend that definition to think about open loops and closed loops. So an open loop, that's where the human is in the loop. A human is sort of, that was that earlier graphic I showed you, where humans expected to provide some sort of inputs or some sort of babysitting in the middle of that agentic loop. A closed loop is when you give the agent the ability to self-verify that it's completed its job. And every time it does the loop, it gets a little better, a little closer to the final solution, and the human is not in the loop, so therefore it is a closed loop. To drill down a little bit, open loop starts right here in this user feedback, user input kind of stage. You send a prompt, and the first time obviously you're not done, so then the agent goes and uses tools. You look at what it's done, and then you decide, oh, is there more more feedback I should give, or is the goal already achieved? This is the open loop. The closed loop looks more like this. You give one prompt, and then this purple is the agentic loop, the closed agentic loop going observe, act, verify. I'm going to talk about what observe and verify means, but basically it is going over and over again, getting closer and closer until eventually it itself decides that the goal has been achieved. So to start closing the loop, there's this concept of verification, verify on the last slide. In order for an agent to successfully verify what it's done, is you want to first define the definition of done. And so this is for most engineers, who start in that like pair programmer mindset. This mostly requires like a moving up the layer of abstraction a bit. Instead of saying, hey, I want you to design like these API endpoints, you take a step back and you think more about, what is the user story I'm trying to accomplish? How is the consumer of this? So you might say, implement this full stack UI element with this sort of behavior when someone clicks this button, as opposed to talking about the specific API endpoints. And then after you have that definition of done, the next step is you actually have to give your agent the tools that it needs to properly verify that the definition of done is accomplished at a given point in time. So examples of this, and like one we'll get into live here in a second is the Playwright MCP server. So browser automation is an extremely good tool, very common tool. It's not just for verifying UI, right? Like if you're a front end developer, it has an obvious application. But even if you're a back end engineer of some sort, and there is like an admin dashboard that leverages the API endpoints that you're creating or whatnot, like it can still be this sort of end-to-end test for your system and a way to close the loop. Then there's like some non-MCP ways of thinking about this too, and you know can include MCP, but it can also be like a CLI tool that hits the GitHub Actions, GitHub Actions as a CI, where your agent basically knows it's not done with its work until it pushes a PR and CI passes. That's like another example of a trick that helps to close the loop. And then like the whole list of all the possible SaaSes, MCP servers that you could have. So for example, if you're building a Slack integration for your product, you might want to set up a Slack MCP server to help you close the loop when you like send a message. Like, does it actually trigger the Slack bot that triggers the right thing in your own app? But you know, replace Slack here with any sort of SaaS, and you have the same gist here. Very important call out. It is extremely important to get yourself entirely out of the loop. Some people I work with, they end up thinking like, oh, like I've mostly closed the loop, but there's this very annoying step, like I need to do OAuth or something in my developer flow, and so I can't just have Playwright spin up an instance, and then they're just like, well, that's fine, it's just one thing and I'll do it. But that makes a huge difference, an order of magnitude difference in agentic engineering, because if you have to be in the loop, you have to be checking in every 1 to 2 minutes, even if it's a very small thing. That means you can't do anything else or you can do very little else while your agent is going. And your agent will do more loops than the average human because you probably haven't built out a really great context engineering harness for it yet. So, and like that's the next step after building your first loops, is to get the kind of cycle time down. But initially it will take a lot of loops, and so like it will be frustrating to have to over and over again do the little auth dance for it, just because you couldn't set up an MCP server to close that loop out of the gate. So the sort of rule of thumb is, if can an agent get to the point where it can confirm success without pinging you? And if that answer is no, then the loop is not yet closed. So beyond verification, the other sort of pillar here is observability, where verification tells you if the loop is done. Observability is what helps you make the loop smaller. So whereas like a verified loop is sort of the happy path, this is the sort of next layer that sometimes is a critical layer that it doesn't work without it. But basically the point is that like by giving access to things like debug logs or database state, I'll get into some examples here, like logging infrastructure, database access, things like understanding what environment variables are in play in your deployed environment, if that's what you're troubleshooting. Having these things is often very important to a loop, because if it's just guessing at what the problem might be and making a code change and then deploying it or running your dev server, and it doesn't actually have insight into things like logs, it will take a long time. Maybe it'll never converge. And so like observability sometimes is just as important here. So let's jump into an example. This is a mildly contrived scenario, but basically let's just say your task is to add in some new UX flow to your app. The agent, you have a ticket that well defines what this feature is, and we're gonna use the Playwright MCP server to demonstrate how this can be done. And so the example, I've pre-recorded this video just so we can skip around in it, since just the agentic action itself takes almost 10 minutes. But basically you can go to, if you want to follow along, github.com/pulsemcp/content, and then go to this demo1 folder. What I've done is like, we have a linear clone, just a clone of the linear SaaS app, a very primitive one at that. And what I want to do is add the ability to it doesn't have the ability to assign tickets to someone. And so what you'll see here, and I'll fast forward a bit just so I can show you the UI, what you see here is a linear kind of app, and the thing that we're adding is the ability to add assignees here. So this is a new feature that it's adding. Rewinding here a bit, it's just so we can see what prompt we start with. So when I kick off Claude here, I basically say, implement this ticket. Keep iterating until you have used the Playwright MCP server to step through the acceptance criteria to verify everything works end-to-end, fix all bugs, and route until you achieve this. And then I just copy paste the Jira ticket. So this is the kind of Jira ticket you might expect to see from a product manager with a set of acceptance criteria written from the perspective of the user there at the end. And then it runs. And this goes on for 10 minutes and ultimately accomplishes the goal. Most interesting is, the obvious, which is that partway through is when it takes the first pass at implementing the feature. And then this is where normally it'd be like, okay, I'm done. Now, can you check my work? Tell me if it's correct, if I'm done, if we want to do a different task. And now instead, because of the way we've set this up, it's going to use the Playwright MCP server and spin up and actually try to see, hey, is my feature working? The way I set this up, I knew there was actually a non-trivial feature to implement. There was like a wrinkle here where even when it does the database migration and does everything right, there's like a bug in the UI where the modal for saving an assignee basically crashes and doesn't successfully save an assignee, and it's a very subtle bug. And so you can see here, like, this is at the point where it discovers this bug. Like, it thought it was done, and now it got to the point, and I still haven't done anything besides the initial prompt. It got to the point where it timed out waiting for the modal to disappear and the assignee to get set, and it failed. And so now it's like, oh, there's still another bug, and it goes and then makes another code change, again, without any of my intervention. And then it gets to the end, and gets to the end, and the feature works end to end, and it's verified that. So that was a demo of how the Playwright MCP server basically helped it self-verify its work, and then helped the coding agent self-verify its work given a definition of done up front. And it found, it saved me, the engineer, a bunch of time because I didn't have to babysit it, didn't have to find out for myself that there was like multiple layers to this problem. And this was a pretty contrived problem. There were only 2 layers. Many engineering problems have 5, 10, 15 layers en route to delivering a ticket. So the highlight here is MCP's role. It serves 2 purposes, and in demo 2, the second one will be a little clearer. But in the first one, the idea of connecting to another service. In this case, it was just the browser. I think that if you're familiar with common MCP servers, there's a whole lot more than just browsers. There's all kinds of SaaS apps you want to connect to and so on. So anytime integrations are relevant, or in demo 2, like when you're doing any sort of on-call triage or whatnot, is where the idea of connections is interesting. There's obviously alternatives like CLI tools or whatnot. I'll save that for another talk, but the kind of fundamental primitive that MCP helps with is the connection one. The constraining one is interesting because it makes MCP, and I'd say this is an underrated feature of MCP, but the idea that you can, for example, with a tweak of a config, change your Postgres MCP server from read-write to read-only for one session versus another makes it much safer and easier to wrangle agents to to lower your blast radius and help them do only what you want. So these are the 2 pillars of why MCP is so useful in closing agentic loops. And demo 2, I'm not going to have enough time to get through the entire demo here, but just to give you a sense for, and anyone can, I'll post the video alongside the slides of the demo video alongside the slides. But the basic idea here that I did was I take the Slack MCP, an AppSignal MCP, which is like a Datadog alternative, a Postgres MCP, and a Playwright MCP, and had it work through a bug that I created on the Pulse MCP staging environment. So there was a bug. It was when you go to a certain page, we were getting an internal server error. And then I hooked up those 4 MCP servers, which did this sequence of, I gave it a link from Slack where I was like, hey, I got an alert. Can you triage this? So I used the Slack MCP server to be like, hey, what's the alert? It figured out it's from AppSignal. It went to these AppSignal MCP. It did a bunch of log searches. It figured out it was this particular page. Then it went to the Postgres MCP server, tried to figure out what's wrong with the data on that page. It found some corrupt data related to that particular record. And then it went through and deployed a code change to staging. And then finally, the Playwright MCP server figured out that the bug was gone. It was done. Mission complete. And then at the end of this all, it had a PR with the issue precisely solved, and the no longer getting a 500 error. And that was a 14-minute Agentic session for it. So I'll leave you with how to action this. Take a look at pulsemcp.com/posts. We have a post about agentic engineering that gets into a very similar topic that what we covered here, just in a little more depth and less MCP specific. And one big recommendation I have is if you're sitting down to figure out here are all the systems that we use at our engineering team, map them out, figure out how to configure an MCP server for each one, and then when you sit down to do something complex like triage an error from 4 different systems, you already have that ready to go. You don't feel like you need to do an hour of configuration that for you to actually start trying to use this stuff when the moment calls. There's many layers to this. It's not after you get to the point of I've built my first closed loop. There's so many other things like MCP optimizations, agent skills. I can talk for hours about what comes next. But the closing the agentic loop and building your first closed loops with MCP often at the core of them is the unlock to a lot of agentic engineering opportunity. So thanks for listening. That's all I've got for you today. If anyone in the audience is in the market for a custom MCP catalog or custom servers built for their teams or enterprises, that's something we do at Pulse MCP, and we take on a small number of clients to do this sort of hands-on consulting where we work with you and your team on adopting patterns like this, working with skills, working with MCP, and tracking KPIs. So reach out to me. Would love to hear from you. Thanks.
Hey, all right. Thanks, Tadas. Really appreciate that session distinguishing open loop from closed loop, talking about how MCP plays the role of connector and controller, connecting and constraining what you can do. There are a couple of really good examples there of Playwright and GitHub, and we just dropped a link to the GitHub repo into the YouTube chat so that you can follow along with Tadas's demo. Next, we're going to move to another point of comparison, not open and closed loops, but skills and MCP servers. And Serge from Sentry is going to help us understand that these are not substitutes, that they're complements that can be used together to do particularly powerful things. So I'm going to hand things over to Serge. Thanks for joining us, Serge.
What's up, y'all? Welcome to Is MCP a Skill Issue? My name is Serge. I'm a developer experience engineer here at Sentry, and I'm really excited to talk about MCPs and skills. But before we begin, maybe some of you don't know what Sentry is. So real quick, Sentry is application monitoring for every developer. We have error tracking, performance monitoring, logs, metrics. We also do AI and MCP server monitoring, and more than 158,000 organizations use Sentry to figure out what broke, why it broke, and how to fix it faster. Now, this presentation might be dated in a week or a month, or some of this information is also already probably a little bit stale, but there is this debate going on right now in the industry where some people are saying that they stopped using MCP servers because it consumed a lot of tokens upfront, and they're saying skills just work better. But the way that Sentry and I look at it is skills teach you how to cook, and the MCP server gives you the tools, and it actually misses the whole point. Now, both are technically right. That's the interesting part. So why do we care? Well, because we operate at pretty much all of the layers that this debate is around. So we make sure that you're set up with error monitoring, performance tracing, and logs. We do have an MCP server. It's open source. It has auth baked into it. And it's, from what we hear, is pretty good. But we also understand the limitations of MCP servers in certain situations. And so we also have skills that orchestrate those tools, but we also have a CLI that you can use within those skills. You can always go check out both the MCP server and our skills at github.com/getsentry, Sentry for AI for skills, and then /Sentry/Sentry-MCP for the MCP server. We also have this really cool thing where our MCP server actually has an experimental flag that only exposes one tool call, and there's an embedded LLM inside of the MCP tool that wraps its own MCP server inside of it, and it becomes a client for that server. I don't know if you know that exhibit meme where we put an MCP server inside your MCP server and stuff like that, but that's not the point of this presentation. But we do ship MCP observability. So if you are building an MCP server, please check out Sentry MCP monitoring. This is a screenshot from our MCP server inside Sentry. You can track your traffic, tokens, tool calls, and breakdown of the transports that people are using. So what is an MCP server? An MCP server is a standardized interface for any LLM to be able to create a client and consume that server. Tools are defined as capabilities with a schema, a descriptor, and a handler per tool. They are auth aware, so if you have situations where some things are accessible and some things aren't, it's really hard to compact that knowledge into a skill and for it to be able to work effectively. But for example, with Sentry, we have this AI debugger called Seer, but some teams might not need to use it. And so we set up our MCP server to handle that. And so if you don't have access to Seer, that tool won't be available to you inside the MCP server. This is an example of what an MCP definition for a tool could look like. You have a name, description, and an input schema. And then the LLM decides which tools to call when. Now, one of the bigger issues with MCP servers is that when you start a new session, so you go to Claude and you say, Claude, it spins up a session for you, and all of the MCP servers that are connected get injected into the context right away. That way, when you do need to use it, Claude has the context of what tools are available, what's their schema definition, and it's able to effectively use those tools. But if you have a bunch of MCP servers, your context window in which you can actually operate and do something meaningful shrinks, and that causes a lot of issues and frustrations. And so that's the overhead before you even type in a single prompt. So the criticism of MCP servers is valid in this case. But not everything needs to be an MCP server. And this is kind of a rough model that I put together where if you have auth and identity and different scope levels for different tools, and you have a pretty complex system that you need to expose to the agents, MCP really shines in those situations. Obviously, live data to be able to access that, always on steering, so the agent always knows and is aware of the tools that you have, and the structure in which the response comes from the MCP is configured for the LLMs to be able to inject it properly. But we have seen MCP servers in the wild that just wrap a single REST endpoint. They also might create a wrapper for your CLI command, which then becomes this abstraction that doesn't really need to be there. And it adds a bunch of overhead and tokens that a single curl command can run a lot more effectively. And so that becomes not a protocol problem, but really, should that exist problem. And so what is a skill? And some people are saying that a skill is just a markdown file, but it really isn't. It's an orchestration that invokes tools, CLIs, sub-agents, whatever you call it. The way that it works is you can have reference material inside your skill folder, and that skill can then progressively understand what are some of the things that it can do, can't do, how to steer agents into the right direction. And so, as I mentioned before, we also have a CLI command, and we have a skill that is available to let agents understand how to use that CLI properly. But the idea is that we give you both options, and both have different trade-offs, and it's up to you to understand which one serves your needs better. And so if we take a look at this Venn diagram, MCPs are where you have your protocol and the wire format. It has auth permissions baked into it. It's accessing live data, it's real time. And skills provide that token efficient routing, progressive disclosure. They really craft the behavior of your agent that it should follow. Could have no overhead. There's no server. You can just get away with a skill and a CLI command if you need real data. So they do share. There is an overlap where they're both really portable. They are invoked by agents, and they're pretty composable. And if we drill into how a skill works, is upfront you have your YAML formatter, which gives you the name of the skill and the description so that the agent is aware that if somebody's prompting something that's relevant to that skill, it'll actually load it up. And then you get your full markdown body of the skill with the referencing files, and that comes later. So it's not invoked if you don't explicitly need it, which is great. And so with skill routing, you can get away with initially only loading 50 tokens or whatever, whereas with MCP, you get the full context load in the beginning. And those tool descriptions become important for the agent to understand the availability of them. If they don't exist, the agent doesn't know that that functionality exists. There are a few efforts from different players in the MCP skill game that are trying to solve this token cost problem. Anthropic recently came out with this tool search concept where if you load up a new Claude Code session and your total MCP token cost is more than 10,000 tokens, it actually hides all of that up front, and there exists this pattern of defer loading. And so if a query comes in that gets interpreted as something that might need an MCP tool, it will use this tool search to figure out if there is a tool that exists that can help with that input. So it kind of follows that same idea as skills, where it's progressive disclosure, and as soon as you don't need that tool, it hides it away from the context. Cloudflare also recently put out a blog post where they turned their tremendously large API into this thing called code mode, where instead of 1.17 million tokens for 2,500 endpoints that they have, it's about 1,000 tokens. And there's just two tools that they expose, which is like searching the API and executing it and reasoning about it. So it's solving it at the code level. And of course, people are using skills in conjunction with a CLI, that if you have a CLI that's authenticated, you would be able to get the same data from somewhere as you would be able to do it with an MCP server. So it really depends on what you are building and what functionality you want exposed to the users of your MCP server, CLI, or your application. One interesting thing that we're doing with Sentry is our MCP actually has an experimental flag that you can enable, and then all that it's doing is exposing one tool called use Sentry, and that in itself has an embedded LLM and agent that spins up its own server and then reasons about it within that context of that single tool call. So if you query find slow API calls, it spins up the in-memory MCP server, and the agent itself will reason about it and give you the right information in your client, which is Claude Code, Cursor, or whatever. So if we look at data and how it can get to your agents, there are 3 different ways that you can do it. You can do it with a skill and an MCP server. You can do it with a skill and a CLI. And you can also experiment with this LLM reasoning inside one single tool call. And that offloads the context consumption and usage to the server. So a user using the experimental flag, their own LLM doesn't need to do a lot of the heavy lifting that the embedded LLM will do inside the use Sentry MCP tool. That has its own trade-offs. And again, we're essentially covering the cost of the LLM at the client level, doing all that inference and understanding what data is needed to the client that is requesting that data. And so if we were to take a look at an example, let's say you're on call and you need to aggregate all the logs that exist in your application. If you only have the skill and you don't have anything connected to it, you can tell it to do something like grep and tail all of the logs from your server, but it might not have additional context that exists somewhere else in your system. And on the flip side, if you only have MCP tooling, it's up to the way that you craft that input for the MCP to understand the actual data that you need out of it. And if you have a bunch of different tool calls, it's very non-deterministic for the agent to understand how to properly combine all the different tools where you need to get the logs, you need to get metrics, and you need to put it all together into a cohesive understanding of what is actually happening. And so with the combination of a skill and an MCP, it gives the agent that you're interacting with a very clear set of guidelines as to how to properly understand what to do with examples of what are some common queries that people run and what are the tool calls that are associated with that. And so the skill is able to route your input into the proper tools that are exposed on the MCP server. If you have an embedded agent in your MCP or whichever way it's crafted, it'll be able to get the data set that is going to be the most helpful for you to explore the issues, and it'll return it back in a structured result for your client to be able to consume it properly. And so if you want to set up observability on your MCP servers to understand how your users are using them, you can do that with Sentry, and you'll get a really good insight into all of the different steps that are happening and how it relates to the rest of your system. So the Sentry MCP will call APIs within Sentry. It'll also do other things, and getting that visibility all in one place has been really helpful in understanding how to make a more effective MCP server at the end of the day. And when you're debugging your own MCP servers, you can use the Sentry MCP server to help you get the data that you need to do that. In terms of takeaways, MCPs and skills, in my perspective, solve different problems. MCPs solve the authentication, live data, standardized interface. Skills are routing behavior and progressive disclosure. It's up to you how you want to implement your skills, CLIs, MCP servers. It's whether it's the outer agent with a skill prompt or embedded inside the MCP tool. The possibilities are endless. But at the end of the day, token cost is a real thing. And so you want to make sure that you're designing your tools to optimize the end user experience. Things are changing very quickly in the industry, and I'm not sure what it's going to look like over the next few months. But it is something that you have to keep in mind right now, because it's always important to make sure that your users have the best experience they can. And if we were to summarize when to use what, if you need auth and live data, and you want to make sure that the agent is always aware of all of the capabilities that it has, MCP server is a great option for that. But also you can use a skill with a bash or CLI tools that could suffice depending on the permission levels that you need to worry about in your application. Is it easy to understand what, based on the user input, what tools need to be called? Well, then you could get away with a simple tool list. But if you have complex querying, then a natural language embedded LLM agent inside your MCP server might actually help construct those complex queries and return to the user the things that they're actually looking for. And if you are worried about token overhead, then obviously you can use a skill with a sub agent, or you can check out the tool search that is coming out from Anthropic. And if you have a huge API surface, maybe looking at code mode from Cloudflare. So is MCP a skill issue? I think MCP is a protocol issue, an access issue, a permission issue, and skills are a behavior issue, a routing issue, a context issue. They're not competing, they're collaborating. Here are some resources. We have links for our MCP server, our MCP observability, the tracing setup for applications that are using MCP servers. I also linked the tool search API, the source code for the MCP server, our skills, and the blog post from Cloudflare for code mode. Thanks so much for watching. See ya.
Thank you very much, Serge. I really like the core message there, that oftentimes there are attention-grabbing headlines that declare one approach as being superior, the only way to do it. It's, of course, much more nuanced than that. We have to think about how we use skills and MCP servers and tools and workflows all together in order to get the best possible results. We really appreciate the thoughtful session and all the practical examples, Serge. Okay, we're going to go on to the next session now. It's going to be led by my colleague from Stacklok, Dan. Dan is our technical marketing engineer, and he's going to talk about registries. Now, before today's event, we had a short 3-question survey that we sent out. About 100 people answered, and one of the questions in the survey asked, are developers in your organization using MCP servers in rogue fashion without oversight? 30% of respondents said yes, definitely developers are using MCP servers in that rogue fashion. Another 27% said probably, but we don't have visibility. So Shadow MCP is a real challenge in organizations with all of the energy behind MCP at the moment. And a registry that's curated and vetted is one of the ways that you can take back some control. Dan's going to share some of those ideas with us now. Over to you, Dan.
Hey everyone. I'm Dan Barr. I'm a technical marketing engineer at Stacklok, and today I'm going to talk to you about MCP registries and why they matter and why they're so important. Now, recently we sat down with an engineering leader at a large software company and we asked them how many MCP servers they thought they were running. And they were pretty confident that the answer was 4 or 5. So, we followed up with a simple discovery script that ran across their environment, and as it turns out, the actual number was closer to 30. They found MCP servers connected to production databases, customer data lakes, third-party SaaS APIs, and none of them were cataloged or governed in any way. And it's not that anyone was being negligent or malicious, they just had no rules or systems around this. And at an organizational level, there was no visibility. And this is not an unusual story. We hear this all the time. It's really the default state for most enterprises today when it comes to MCP. MCP promises this universal protocol, right, connecting AI agents to tools, data, services, and adoption has been accelerating. We see thousands of community and vendor-built servers, internal teams building their own on top of that, and developers rightly love the productivity gains. There's a good reason for that accelerating velocity, but without visibility, this creates real governance problems in the enterprise. And these two forces of developer velocity and organizational control don't have to be at odds. But without having the right infrastructure and systems in place, it's pretty inevitable. Now, these downstream effects show up in a few different ways. The first is discoverability gaps. In engineering organizations, multiple teams end up building the same solutions independently, or running the same tools in different ways with different implementations, and all this leads to inconsistent behavior and results and duplication of effort. The second is shadow MCP, which is really part of the broader concept of shadow AI. And you can think about this in the same way as we saw years ago when public cloud technologies led to shadow IT. In enterprises of all sizes, MCP servers are getting stood up before governance frameworks have had a chance to catch up. Security teams are then having to go back to discover and remediate these deployments retroactively, and that's a really difficult problem to solve after the fact, and it ends up causing a lot of friction between teams. And the third is compliance exposure. Regulated industries like financial services, healthcare, defense, they all need to be able to answer the question, what data can your AI agents access? And without a system of record, the honest answer is, we don't know. And that just does not cut it with auditors. This isn't a new problem. We have seen this before, and it reminds us of the early days of container adoption. It looked exactly like this. There was sprawl, duplication, shadow deployments, security teams playing catch-up. And the organizations that recognized this early and put in the right systems and infrastructure, like registries, operators, policy engines, they're the ones who were able to leverage this technology and they came out ahead. The ones that didn't might still be cleaning up. And MCP is at this same inflection point. The solution, it turns out, is also the same. It's registries. A single system of record for what exists, what's approved, and what can be used. So what is an MCP registry? Well, at its simplest, it's a catalog of MCP servers. It's a system of record for what AI agents are allowed to use in your organization. And we see it delivering value across 4 main pillars. The first is discovery. Developers and end users can find the right tools without having to open a ticket or ask someone in Slack. Right? And that frees up platform teams from being this human lookup table, constantly answering the question, hey, does this thing already exist? How do I connect to this? So that they can move on to focus on more valuable work. The second is governance. When admins and security teams are able to define which servers are approved, who can use them, and how they are consumed, that means policy gets to move out of spreadsheets and word of mouth and into something that can actually be audited and enforced. Enabling trust and provenance is important too when every server entry carries metadata, things like publishers, versions, approval status, security signatures, everything you need to answer the question, where does this come from and who approved it and when? And finally, lifecycle management. When a server is retired or updated, patched, the people who are using it need to know immediately. And without this, deprecated servers and outdated servers just keep running and security patches don't get propagated. So together, these 4 things really help you turn MCP from the Wild West into something you can actually manage within an enterprise. Now, before we take a look at what this looks like in practice with a demo, it's worth doing some orientation on the MCP registry ecosystem because there has been a lot going on here already. At the foundation, there's the registry server API and publishing format. This is the open standard that makes everything else interoperable, and any registry that implements the spec can participate in this ecosystem, both upstream and downstream of other registries and clients that need to consume them. And importantly, the spec leaves room for custom extensions and metadata. And it's also important to understand that this is a metadata registry that describes servers, things like where to locate them, how to execute them, but it doesn't actually store the artifacts of the servers themselves. That's still left to existing methods like container and package registries that we're all familiar with. Now, built on top of that is the official MCP registry. This is backed by the major contributors in the MCP ecosystem, and it's the canonical public implementation of the standard API, and it's the source of truth for publicly available MCP servers. Now, below that, we have downstream aggregators and marketplaces. These are typically run by vendors like GitHub, Docker, and Anthropic for the Claude marketplace. These pull from the official registry, but they layer on more opinionated user experiences like discovery UIs, curation, extra metadata related to their point of view. But these public registries don't really fully address the enterprise layer. The official registry explicitly doesn't support private MCP servers, and that's its design, and that's fine. But what enterprises need is an internal governed catalog. The catalog of vetted, approved servers with things like default configurations baked in to make end-user consumption easier. Authorization policies applied throughout. It's the source of truth for what's allowed within an organization and how to use it. And this is where the ToolHive registry server operates. ToolHive is our open source MCP management platform. It underpins the Stacklok Enterprise MCP solution, and the registry server is one of the core components, along with a secure runtime, gateway, desktop, and web portals on top of that. So let's quickly take a look at what this might look like. Here's a view of my registry. It's, of course, using the ToolHive registry server underneath, with our Cloud UI on top acting as a front end to the registry contents. I've included a few different collections of MCP servers here from different sources. There's a few here from the official upstream community registry, a handful from the ToolHive registry that's maintained by our team here at Stacklok, with a mix of remote MCPs and local ones that I could launch using the ToolHive desktop app. And the registry is also automatically discovering the MCP servers that are running in my Kubernetes cluster using the ToolHive operator. And of course, all of this is in a searchable interface with the kind of metadata that you need to actually determine whether this MCP server is right for your use case. So that's a quick look at the catalog view, right? A developer looking for, say, a database connector or an internal API server can find it in a few seconds with all the context they need and no Slack thread or Jira ticket required. Now, before we go any deeper on that, a little bit of context here on how we're building this and how we're thinking about this. So Stacklok was founded by one of the co-creators of Kubernetes, and we lived through this container sprawl era. And we really bring that platform-centric view to everything we do. There's a few key principles that have guided our design of the ToolHive registry server. One that we just saw is multi-source. We know that enterprises are going to have servers coming from all over. maybe some trusted servers from the public registries, definitely a curated list of community or custom internal MCP servers that are tracked in a Git repo, and also these shared deployments running in Kubernetes. And the registry pulls all of this together into a single catalog. Of course, authentication and authorization needs to be fully integrated, and it needs to plug into your existing identity providers. Virtual registries are another concept, and this allows you to create role-based views out of these multiple upstream sources that are tailored to different teams or workflows without having to duplicate all of the data and records in the registry. And of course, we've put a lot of thought into the lifecycle where admins are going to curate and publish servers, and end users simply discover and connect to those tools as part of their normal workflow. So I'll go back to the demo and we can see more of that loop in action. I'll start by running a new MCP server in my Kubernetes cluster, and we'll see it appear in the registry automatically. And then I'll connect to it from an IDE with just a few clicks. So here I have a manifest for an MCP server resource that is going to be deployed using the ToolHive operator. When I apply this, ToolHive will spin up the containerized Prometheus MCP server with a secure proxy in front of it, and I've also defined an HTTP route that will expose it using my gateway controller. And these annotations are what allow the registry server to automatically discover the metadata for this server once it's running. Now that I've applied that and the server has been created in the cluster, I'll come back to my catalog view here and refresh the Kubernetes view, and we can see the Prometheus server is already appearing here in the catalog. It has all the metadata I need to be able to connect to it, including the URL and the tools that are available through it, so I can make sure this is the right server and tool for my use case. Now all I need to do to connect to it is to add it to my favorite client or IDE, like Cursor, VS Code, Claude Code, really anything that speaks MCP. And again, just a few clicks, just a few seconds, I now have these tools available inside my IDE and I can start using them. Now, of course, in a real enterprise scenario, this all would have been wrapped with an authentication workflow through my identity provider to make sure that I should actually be using this server and these tools. So you can see that a registry isn't just about discovery or governance, but it can also be an accelerator for user and agent workflows. So what's next? Well, a registry is foundational, but it's not the end state. It's a layer that makes everything above it possible, things like discovery portals, MCP runtimes, secure gateways. As the ecosystem matures, we think registries will need to surface not just MCP servers and tools, but also reusable workflows, specifically in the form of agent skills. We see the catalog growing from a tool directory into something more like a full agent capability and context layer. There is an active interest group in the MCP community about the intersection of tools and MCP, and one of the recent additions we've just made to the ToolHive registry server allows you to publish skill metadata into the registry right alongside MCP servers. The next is improving discovery, making it easier not just for humans to discover tools, but also for agents. One idea here is turning the registry itself into an MCP server so that agents can start to assemble tool chains dynamically from the pre-approved set of tools in your registry. Another approach here is Stacklok's MCP optimizer. This turns a collection of tools into a dynamically searchable index and surfaces just the right tools only when they're needed, which improves agent performance and tool selection and also cuts your token bill. And finally, an important part of governance is moving it from manual processes into code. Driving policy as code into every layer means rules get evaluated at deploy time and runtime, and decisions become auditable and enforceable. They're not buried in email threads that nobody can find 6 months down the road. And we think the organizations that build this infrastructure now will be the ones that can scale AI agents effectively, safely, and quickly, and really take advantage of this velocity in the ecosystem. And the ones that don't will probably spend the next few years cleaning up. So I'll leave you with the principle that drives how we think about things. The harder you make something to do, the more likely someone is to violate the controls. And I'm not trying to be cynical here, it's just how things work. This is one of those laws of organizations, right? If finding an approved MCP server takes 3 days and a Jira ticket, developers will just use the one they found on GitHub. If it takes 10 seconds, they won't have a reason to do that. And that's the goal of an MCP registry and everything around it. Make the safe path also be the easy path. So everything I've shown you today with ToolHive is open source. The links are on the side here. We'd love for you to try it out. You can download the desktop app to get running in a few minutes. Check out the projects on GitHub and the docs to get started with the Kubernetes operator. And contact us for a demo of the enterprise capabilities of our platform. Definitely jump into our Discord too. Join the conversation with our engineering team and with the rest of the community. So thanks for watching, and I hope you enjoy the rest of MCP Academy.
Thank you very much, Dan. Much appreciated. Let's see, a couple of key points there on making sure that the secure path is the easy path, putting friction in the right places, removing it from others. One of the other key messages and a focal point for us at Stacklok is making sure that enterprises can use their existing infrastructure as they journey into this world that's more AI native. We want to help them make best use of their Kubernetes footprint and other familiar tools to them. So thanks, Dan, for the session. We're going to move ahead into the middle third of MCP Academy. The middle third is really about optimizing your use of MCP. And first up is Patrick, who is the CEO and co-founder of Clarifai. I've had the chance to actually take a pretty close look at Clarifai as a potential user of the tool. It's AI native go-to-market technology. And Clarifai had a chatbot assistant called Rep that they evolved into more of a full-blown AI agent. And in this session, Patrick is going to share with us some of the decisions that they had to make and the different steps along their journey in evolving that agent. Over to Patrick.
Hi everyone, excited to meet you. My name is Patrick. I'm the co-founder and CEO at Clarifai.ai, and I'm excited to talk to you today about how we transitioned from building a chatbot to building an agent, and how we've optimized our MCP tool selection at scale across both being an MCP server as well as being an MCP client. So let's dive in. But first, what is Clarifai? Clarifai is an AI native CRM. Effectively, we're building an autonomous CRM for early stage startups. We want to spend a lot of time automating as much of the data input as we can so that we can use AI to do things like detect deals, track stage changes, enrich contacts, and automatically update fields for you, effectively auto-capturing and self-updating your pipeline. And we've built an agent named Rep, which is effectively your sales assistant. It can query data, draft emails, build campaigns, and help you prep for meetings. This has been well received by our customers. You can see folks like Nicholas here below. It joins my calls and reads my emails, handling 90% of my data entry, plus it does enrichment, plugging a bunch of gaps for me. And this is the type of feedback that we want to get on the product that we're building, and a lot of that is due to our investment in building an AI-first product. So let's dig in. Why AI native? So most CRMs fail because humans don't do the work to maintain them. Our bet is that AI should do the work for teams. It's not a feature, it's the core foundation of what we're building. We're reimagining the workflow from the ground up so that AI can do the heavy lifting and help automate your go-to-market motion. And the CRM should get smarter the more you use it. This is where context comes in. We want to learn the more you use our product, so effectively we can help better nudge you and guide you as our system gets better and smarter. And it should work where you already are, whether or not that's inside our product, inside of Claude, or in your own MCP framework. So anywhere that MCP is available. And we sit in kind of both sides of the world, right? We have both an MCP server that we expose. It's available inside of the Cloud Marketplace that teams can go install and use right away. It helps you query your CRM data, manage records, and really orchestrate that go-to-market motion from building lists and managing campaigns. And we have our own MCP client. This is effectively Rep, right? It can connect to other MCP servers like Linear, Notion, Granola with one click, and effectively helps you get the data where it lives inside of those tools and do things like orchestrate more complex agents as well. So think about creating success plans inside of Notion that you want to share with customers. I'll walk you through how these both work. So what was the evolution of AI at Clarify? We're a 2-year-old company. We started in the beginning of 2024. We spent a lot of time working on things like ambient AI. So effectively AI that runs in the background required very little if no human interaction at all. So everything from building our own prompts for things like deal detection, where we'd read your email or listen to the call transcript and suggest deals for you. We would auto nudge you based off email threads on when to follow up with people or create follow-up tasks. And we shipped things like AI fields that would automatically update your CRM as more context flowed into our system. In 2025, we moved from more ambient AI to actually launching our first agent experience with Rep, which lives inside the product. It allowed you to ask more complex queries of your CRM data. It's effectively an assistant that had multi-tool use. It could query data, create records for you, draft emails. It was a great experience for us, but it got more complex over time. And so in the end of 2025, we had to invest a lot in kind of our agent core infrastructure to be able to expand out. We've been working in 2026 on building autonomous agents where we can orchestrate more complex journeys across different tools, not just within inside of Clarify. So it started simple. In 2025, we had 2 tools. We had search records and create records. And, our AI was right 95% of the time on what tool to call. It was hard-coded in the system prompt. Life was pretty good here. Then we added more. So you can see in Q2, went from 2 tools to Q3 having 8 tools to Q4 having over 20 different tools. And, tool bloat got large here, and we over time simplified some things. But, as it grew organically, as our product surface area grew as well, we needed to be able to solve this once and for all. And then in 2026, we actually added support for other MCP servers connecting into Rep as an MCP client. And, each of these tools brings its own set of tools into context. So we needed to really solve this problem. So wrong tool selection became an issue, tool blindness, context window bloat, which a lot of folks I think talk about, human descriptions failing right here as well, and then vague external tools. So we wanted to build a system that would not just work for us as we add more tools into Clarify, as our product surface area evolves, but also as we add other MCP servers into our MCP client. The MCP spec tells you how to expose tools. It doesn't tell you how to make agents select the right one, and that's what this talk is about. So what did we learn? Well, for us, we had 2 paths, but the same problem, right? So inside of our own agent rep, user asks a question, we kick off our agent core, which can do up to 15 autonomous turns, right? It has 25 plus internal tools, plus any tools connected via MCP servers, and it streams the response back to the customer, regardless if they're asking inside of our desktop app, our web app, or in tools like Slack. And we have the MCP server implementation where a user asks a question. Clarify is one of many MCP servers that are connected. We have 15 plus tools that we expose there, and it's competing with dozens of other ones. And then the agent has to pick the right tool for the job. And it doesn't always get it right. There's less guidance that we can provide there. So tool descriptions and naming are pretty much our only lever. So we spend a lot of time trying to figure out how to optimize there. And so I'll walk you through and demonstrate some of the things that we have done and some of the issues that we're still facing. So what does Rep do that raw MCP can't? So with Rep, the user creates a message, we have context resolution, so we know where in the product you are, we know what record or list or entity you're looking at. The system prompt is basically assembled from the Rep identity that we have. It has things like the business description, right? So we have a bunch of context that we feed it about your business. We give it tool instructions and additional server metadata. It goes through the agent core, it picks the right tools from a list of available options, and it executes those tools with the workspace scoped authentication, results feedback, and decides the next step autonomously without human intervention. And the human can watch what it's doing in the background, and it can do things like parallel tool call execution as well. And then the MCP client integration, again, we have internal tools that we expose, we have the external tools that we can expose, and then full schemas fetched on demand for all the tools. And then again, we stream the response back. So it's a much nicer customer experience because of all the context, the prompt engineering, and the multi-turn reasoning and routing that we do here versus what the customer gets with just the MCP server. So let me show you what this looks like. Okay, first and foremost, let me walk you through Clarify. So Clarify by default is connected into things like my Google Workspace. So you can see for my meetings that I had, you can see that we had this chat experience. This is effectively rep over here. You know, what were the key takeaways? What action items were discussed? Draft me a follow-up email. You can see that it has things like context here. I can add context for any of the recent deals or meetings that I've had here. And this is where customers can come in and interact with Clarify via this agent style experience. It's pretty much omnipresent. It follows you around the product. It's always available, and it gets smarter the more you use it. So let's walk through some of the context that Rep has available to you. So when the customer signs up, we go and fill in a bunch of information, right? We look at things like the company description. So we go do things like internet research. We grab a bunch of information about the company. This gets fine-tuned over time as well. We have things like deal intelligence, so we know what deals you're working in, what gaps you might have as well. Again, this gets tuned over time, but both of these things, right, the company description, broader feature level instructions help provide Rep more context when you're asking it to do discrete tasks as well. Additionally, we have available connectors, right? So you can go connect tools like Linear, Notion, Granola, other custom MCPs as well. This allows us to go access data within these tools as well as, write functions as well. So I can go in, pull data from Granola, grab context or deal information from Clarify, and then write a page in Notion. Or, as an example, we have a lot of call transcript data in Clarify, so I can go update my product roadmap with any customer feedback or blockers that have come up within deals as well. So this allows us to not only meet the customer where they are, but connect them to the other tools that they're using today. And how does this look inside of Clarify? So you can see down below, we have access to this agent. Again, you can see that you have a bunch of connectors here that are available below. So let's run some queries. What is the team working on at the moment? In Linear, stay high level. Right, so by default, I could go to a tool like Claude to do this, but it's nice to be able to go here and I'll refine this based off some deal information in a few turns. You can see that it's finding the right tools. It found 5 tools here. I'll pull up the active projects and recently updated issues in Linear to give you a high-level overview. You can see it's listing the projects. And you can see upcoming as well, things that it might be working on. Cool. So now I want you to So I'm going to have it cross-reference the active deals. What's missing as potential blockers for sales. Here you can see the response. It found some blockers. It looked at the read active deals. So you can see it actually generated the query, ran the query, and then gave me a response of things that are potentially slowing down some of our deals that we might want to focus on. So let me show you what this experience would look like for a common question in a tool like Work. So the problem that we have with generalized agent frameworks and like Claude Code here, which is connected to a bunch of different MCPs, if I say, hey, what sales calls do I have this upcoming week? It's actually calling the Google Workspace MCP tools to get events here. It found a few meetings that I have for this week. It's pulling in some roundtables, a kind of an annual, it has this meeting with Rob and this meeting with Graham as Zeta. Okay, do this search, but search Clarify. Clarify obviously is our system record for all things sales, so it would have been nice if Claude had chosen to search Clarify earlier. Here you can see that it actually pulled in those same 2 meetings, but has way richer context, right? So Monday, Rob Walter, CRO at Commerce, based in Wake Forest, North Carolina, lives with wife and 3 kids, enjoys golf, has 2 Clarify records, BigCommerce and Commerce emails. You can see that there's a related deal previously. Last email interaction was February 18th, and it has a link to the record. Same thing with Zeta, a bunch more information. You can see that there's an active deal in flight with Zeta, as well as more information here. So this is the general issue that we face when building both an MCP server as well as MCP client, is if customers are interacting in tools like Claude or Cursor and just via MCP, is those agents don't necessarily have enough context about their business to understand what tools to call effectively. And so here I have to nudge it as a customer to get the information that we need in order for us to present a good customer experience. And we found that even in other types of surface areas like Slack here, as an example, where customers might decide to add something like Claude, we wanted to actually create more first-class integration. So we actually have our own Slack app that can run where customers can interact with Rep. So here's an example where I have a new channel where I can invite Rep, and you can see by default Rep can do a variety of different things for me, right? It can answer questions around my CRM data and insights. It can, how many open deals do I have? Who did I last meet with at Acme? It can read and search emails, summarize meeting recordings and transcripts. It can go create and update records. It can do pipeline and sales analytics, which is really, really helpful. And then you can see, again, that it has access to those specialized tools that I connected, or MCP servers that I connected earlier. So let's go here and run a query for Rep. So let me add Rep and go ask a question. Without showing customer names, what are the top 3 things that customers like about our AI? Provide quotes. Okay, here you can see Rep is starting to think, and you'll start seeing information streamed back to Slack here as it starts to process the information. Reading customer testimonials, reading adoption notes and health assessments. Okay, we got an answer. Let's go look. Hey, based on customer testimonials and deal records, here are the top 3 things customers love about Clarify's AI. AI-powered meeting intelligence and automation. The automated meeting summaries and action items save us a significant amount of time. AI-driven relationship context intelligence. Customer loves how Clarify AI surfaces relationship context that never had before. AI search enrichment and daily summaries. The AI capabilities, especially daily email summaries and predictive search, have been game changers for our team. Cool. That's awesome to hear. I think the reason that's worth highlighting this is because if you're building an agent, you might be building an agent just inside of your product experience, but that agent might be exposed as well. And so that's what we've done here with Slack, but you can think about us expanding this out to be able to do things like iMessaging, right, in the future, or WhatsApp, or exposing our agent via other types of protocols where customers can interact with it, where we have more fine-grained control of how that agent operates versus what you saw earlier in things like Claude Code. And lastly, I want to show how you can also orchestrate more complex experiences with things like Notion connected. So I just asked our agent to create me a Notion page based on these insights. It's finding the right tools. You can again see it's streaming back creating pages in Markdown. This is what Notion would expect. Here, and you can see that it's responded. The Notion page has been created. Notion, what customers love about Clarify's AI, includes all 3 insights with anonymized quotes organized by sections. Click the link to view or share. Again, you have actually ability to give feedback to our agent here as well. Nice job. Okay, I want to transition over into one other thing, which is experiences like the new lead finder experience that we have inside of Clarify. So this is part of our overall rep experience. Here you can see that we're providing suggestions based on company context. So find early stage SaaS founders evaluating CRM solutions. This was AI generated. When I click on this, you can see it actually submitted a prompt into rep to go find me effectively leads that might be useful for our CRM. It's again finding the right tools. It's running a targeted search here against our ICP. And because this is an agent that can spin a bunch of reps doing this, you can see that it went and actually generated this lead list. It'll continue to refine it over time as well. Again, we give it the ability to go continuously improve here. So I have an answer. You can see it's 56,000 people. It's generating the filters that applied. It has some highlights here for me in particular. I can say, hey, next steps, refine it further, import to CRM, or launch a campaign. But it has this artifact that it generated that I can now share with the team. So again, this is part of our rep experience. It's really easy for me to get feedback on this. Again, and or share this, and I can generate more personalized experiences from this. So because rep has context of where I was in the tool, it knows what tools to go call. So we weight tool selection based off of that context as well. So we talk a lot about the host experience versus the guest experience. You can see that the host experience, there's more things that we can do for the customer versus the guest experience where we're delegating a lot of that over to Claude. So 6 principles for tool selection at scale that we found helpful. One is deferred tool loading. Second is descriptions as prompts. OAuth gated discovery if you're an MCP client. Server level routing and consistent tool structure. And then this agent native mindset as you continue to build out agents. So first and foremost, deferred tool loading. Without deferred loading, you're loading a bunch of tools into context that consumes a ton of tokens and can confuse the agent over time. We try to defer them. We actually have a tool for searching for tools now, which has been helpful. Second is tool descriptions are prompts, not docs. The more information you can provide in the tool description, the better the agent is at actually figuring out what tool to use. So we think about the description more as a prompt now, and this has been helpful for not just our own internal agent experience rep, but also for things like how it interfaces with Claude. Again, we have a kind of decorator pattern that we use for this. We register this tool with a name, a description, a ZOD input schema, and annotations. It's all authenticated at the workspace level, and then we query data effectively, kind of async here. The OAuth gated tool discovery is, again, because we are a MCP client, not just MCP server, there's other servers that can be connected into rep. So we try to gate the tool discovery there with providing enough information for our system prompt. So if you ask for linear, but linear isn't connected, we know kind of how to prompt you to go connect to linear and other tools as well via custom MCPs. So this has been helpful for us just to create a better customer experience. We're loading tools and caching tools more programmatically here. And then refreshing things like auth tokens if they expire. Something that was a bit of, the system prompt provides us a lot more guidance on how to nudge rep into what to do. So, things like linear here, we have capability hints in the system prompt for managing issues, route to linear server, for meeting notes, route to granola server, if you have both of those things connected. So it just allows us to be able to guide the agent where to look for the individual tool call when we're the client. And we created kind of a consistent tool structure. This allows our broader engineering team to create their own tools as they add features. So, when we add new capabilities into Clarify, we think a lot about what is that AI first experience? How is it exposed via MCP? How is it exposed via the API? This base class pattern has been helpful to kind of enforce standards and conventions as we think about tools as an interface to agents beyond just our API. The stateless request handling is helpful for isolation, right? We don't share state across sessions. It prevents race conditions from happening across concurrent tool calls as well. So, this has been something that I think it's just good engineering practice. And it's limited a lot of ability for the agent to kind of just blow up on the customer. So definitely something I'd recommend doing. The agent native mindset. So in the chatbot era, when we were in 2025, early 2025, it required the human to correct the agent quite a bit. Effective in this agent era where we're building kind of this agent framework for customers to build their own agents, the agent needs to get really good at self-correcting. So the multi-turn has been super helpful. Discovering tools dynamically has been super helpful. And then passing back any of the error information to the agent has been super helpful for it being able to course correct and guide itself if it runs into any issues. So the full flow here is, a customer starts a chat, the agent core initializes, the MCP adapter builds the config, the system prompt assembles all of the tools that are available and the metadata, the agent executes, and then we track all the telemetry for every tool call back to our system to look at things like completion and error rates across tool calls. Recommendations I'd give if you're building an MCP server, right? Tool descriptions like prompts. Again, you saw the example where I was in Claude and asked a sales-oriented question, but Claude decided to defer to Google Workspace MCP versus the Clarify MCP. Use structured input schemas for validation versus freeform. Use human-readable names for UI displays, but provide more context to the agent outside of that. Recurrent consistent formats. Again, the content is error is super helpful for us. And then add a feedback tool that lets agents report when things don't work as expected. It's really hard when you're operating kind of within the black box of somebody else's agent to get data back on how to improve other than talking to your customers. And then again, it's pretty obvious, but keep the tool count. Bloat does matter. Again, we built a tool to make tool calling fairly easy here so that we don't have to blow up the context. And if you're building an MCP client, use deferred tool loading, cache discovery of tools so you're not refetching over time, implement proactive token refresh, and gate tool visibility behind credentials so you're not, again, bloating the context. And again, why do we do this? To make our customers' experience much, much better. Customers are citing rep by name as a reason Clarify is better than the competition. The tools behind it are what makes it work well beyond just our system prompt. So yeah, we're super proud of what we built here. We're just getting started, and some of the things that we've done to create kind of this consistent tool library that can be called both via our client as well as the server have made it much easier to build and manage at scale. Thank you. If you have any questions, feel free to reach out to me. We are definitely hiring engineers here in Seattle who want to build AI native software. And if you want to kick the tires on Clarify, you can try it.
Thanks so much, Patrick. Clarify is an interesting case because it's both MCP client and MCP server. And I really like the 6 principles that Patrick laid out there. We're going to keep rolling. Next up is Edward from U.com. Earlier today, we had a session on MCP servers and skills as complements. Edward is going to show us how to use a single portable markdown file to actually teach an agent exactly when to trigger a specific workflow. We're going to dive into that session right now. Over to Edward.
Hi everyone, I'm Edward. I lead the Agent Skills project at U.com. Today I'm going to show you how to build, test, and improve agent skills as part of your everyday coding workflow. What if your AI agent could learn new capabilities from a single markdown file, and you could prove it works with a single command? That's the question that drove everything I'm about to show you. We wanted a structured, testable, portable format to teach agents new capabilities, and a way to measure whether the teaching worked. You see, the thing about agents is that you fall into a bit of a teachability gap when you're just using MCP servers. And this is where skills come in. Because while MCPs give you tool discovery, type schemas, a great transport layer, and server connectivity, they don't really tell you when to use which tool, auth patterns and best practices, give you error handling strategies, inform you about test scaffolding, or just integration workflows. MCP is incredible for connecting agents to tools, but these are real gaps. Having access to tools and knowing how to use it well, that's where agent skills really shine. So what is a skill? A skill is at its simplest to just say skill.md file. Markdown with a YAML front matter, no SDK, no plugin systems. Any agent can read the text and just use it. But there are also so much more. These are self-contained markdown files that teach the agent how to perform a specific task. They're portable. Like I said, any agent can just read the text. They're evaluable. A discrete unit you can test using an eval strategy, much like we do for models today and agents. And you can improve them. Because it's evaluable, you can iterate on it until you get the evaluation results that you want. Now let's look at the structure of the skill. Inside that front matter, you're going to have a name, and in this one we're using the U.com CLI skill. You have a description, what it does and when to use it. And your agent is going to semantically search for both that name and that description in determining whether or not it's going to trigger and auto-activate that skill. Often people put a license in there. And then there's a list of allowed tools. In the case of our U.com CLI skill, it's curl and JQ. And then finally there's metadata. And that's going to have information about the author, the version, category, and sometimes platform-specific things, like for OpenClaw, which uses its own object, a structure to be passed in for its own usage. And then finally, we get to the meat and potatoes, the body and markdown. And that's where the instructions, workflow examples, security, and troubleshooting references lie. And that body is the agent's readable instructions, and it uses it and the links it finds in it to scripts, references, and assets to be able to either execute those executable scripts in the scripts folder, look at the assets and get access to them, or use the references as templates and further documentation that it might use when it wants to go deeper. And this is what we call progressive disclosure. So moving on, I'm going to say this one more time. Skills aren't all loaded at one time, only the description and title. The agent only loads what you need when you need it. And so we have discovery, looking for that name and description. When the agent determines that the skill is relevant for that, it's going to load that, activate that skill. It's going to get loaded, and that's going to pull in the body. But then you can take it a step further. You can actually look at the links to references and progressively load those as it needs it. And that's execution. Same thing is true for scripts that might be in there. So let's go ahead and watch this first demo. In this first demo, you'll see I'm using a U.com CLI skill. And I'm asking it to quickly research what happened at NVIDIA GTC. I'm approving its use of Bash. It's going ahead and beginning the research process using our research API here at U.com and giving me a summary of what happened. I can see what Jensen said, we'll hear about new hardware. There's stuff in there about Nemotron and the partnerships that were really highlighted. But I'm really curious about the big exciting thing, NemoClaw. So I'm asking for the latest news on that. And now you can see our skill is executing a curl command that we've told it how to do for that search and pulling in the latest news on the NemoClaw from the past month. And then it's going to refine that search by applying it to the research. And then what we're going to get now is a clear look at the latest news about NemoClaw with research insights. Looks like I bought the right machine recently. Got myself a Blackwell workstation of my own, and I'm looking forward to giving OpenClaw a shot using our U.com CLI skills. But just because you can write a skill doesn't mean you're done. You've got to be able to evaluate it to know whether or not it works or not. So a while back, I built a library that allowed me to carry out the approach that Anthropic showed us and their demystifying evals for AI agents. This allows me to evaluate an agent, but I also realized, wait a minute, I could probably evaluate skills too using the same approach because skills are discrete units, they're easy things to think about, and they're actually a little bit simpler than just evaluating one prompt to another prompt because they're measurable, especially ones that are doing like integrations, code scaffolding. In fact, I would say that they are probably the easiest thing to evaluate using that Anthropic approach. And so using that, I put together a pipeline where we take a series of prompts that are what we feel are high level, what a developer would use when using any of our skills. We pass them to our evaluation harness, and we have Claude Code execute those prompts headlessly. Then we pass them to our element as a judge, and in there we have Gemini, or Claude, a different Claude model, judging the output of not just the files that were created, but the test results to tell us whether or not that did it make good files that actually achieved the desired goal of the prompts, and did the tests that were generated for those files also pass. And then to make sure our skills don't get stale, to make sure they're staying in sync with APIs or libraries we may be referencing in the skills, we run weekly CI runs of that. And when one of those skills evals fails, we usually give them two retries. We go ahead and create an issue, and it's up for us to go into that skill, update it, and make sure that it is ready and a new version is released so that whether it's a developer here at U.com or it's a developer using our skills externally, they will have a up-to-date and ready-to-use skills inside their agentic development environment. Time for demo 2, evaluating the skill. In this one, we're going to evaluate a U.com API Python skill. This one teaches your agent about our APIs and teaches the agent how to build Python code that integrates those APIs and test for it. Now, it's a bit of a long one. It takes a while for the agent to spin up and to execute our 2 prompts. And as you can see here, the first prompt is like using the U.com API skill, create a working Python application that calls the U.com research API directly with requests to get a synthesized cited answer to a question. Right? A flat minimal code with no comments or doc strings, write integration tests that call the real API and assert on a meaningful response content. Save everything to the test/U.com API Python directory. Now, it takes a while to do that, so I'm going to zoom through a little bit. And it's gonna get to the point where now it's looking at the output format of that stream, and it's ready for the next prompt. And the next prompt is like, hey, you know what? Let's extend that integration to also call the u.com search and contents API to get raw search results and extract full page contents from the top result URLs. Write that flat minimal code again, no comments or doc strings, and update the integration test to verify that both research API and search content pipelines work with a live query. And we're doing 2 prompts on this because we feel reflects as close as we want to get to simulating a real developer experience when someone's trying to use one of our skills. So the eval is not the fastest thing in the world, but it does get to the point where you can actually see the test running. And then the judge is going to judge everything that came through. Now, we can see that the eval passed, it completed its task, and then we're going to go ahead and generate a summary of that. And in the summary, we're going to see that we got a score of 88. It's not always 100. It passed, and it's going to tell us that all 19 integration tests passed against live APIs. Real API calls confirmed. Tells us the duration of this of all those calls. It was using both search, content, and research, so 20.95 seconds. Seems like reasonable given the different things we're asking it to do. And the assertions validate the response structure and content meaningfully. Now, looking at our scoring rubric, 0.88 isn't the best. We probably can go in and do some work on this skill. And I'm personally working on improving the evaluation harness and tooling I've made inside my personal project, Playdit, and hoping to bring that back into here at u.com to improve our ability to evaluate skills, so that we can get all our skills consistently scoring at 0.92 to 1.0. And this is like where we want to have our skills at most of the time, but we can guarantee our users of our skills that they are getting the best agentic development experience possible. So MCP skills are complementary, they're not competing. Oftentimes, I will design skills that call to MCP servers or give instructions about using an MCP server. And I will provide knowledge about when to use which in the skill, because I feel that's like a good workflow. It helps my agent know how to use this. And a lot of agents now have actually solved the MCP context bloat by using some form of semantic search of the MCP schemas so that they don't bloat your context. Here are 3 things you can do today. Extract your most repeated agent instructions into skills. Write your own eval prompts and build your own evaluation suite so that when you're shipping these skills or sharing them within your organization, you can actually tell fellow employees and your colleagues that your skill is not just reliable, it's capable of what you say it is. That's what that measure PASIC-K is all about. If you want to know more about any of these things, please feel free to check out agentskills.io, check out our Agent Skills repo. If you want to learn more about our evaluation harness, feel free to go to Agent Eval Harness or the Playdit repo. And then I recommend everyone take time to read Anthropic's Demystifying Evals for AI Agents, which did inspire our Agent Eval Harness, which we're using here. Thank you. It's been a pleasure being able to share some time with you. And I hope this helps you and remove some of the chaos from building your skills.
Thanks, Edward. I like the 1-2 punch of creating skills and evaluating skills and using Gemini or Claude as judges that ensure generated files actually pass integration tests. Thanks for that session. We're going to move on to the final session in this middle portion of today's agenda. Hugo from Kong is going to join and talk about context bloat. It's a theme that has been in many of the other sessions today, but Hugo's really going to dig in here. He's going to show us how bloat affects token usage, how it affects model performance, and give us some specific ideas for what we can do about it. Let's go to Hugo.
Hi, hello, and welcome to this session. My name is Hugo. I'm part of the product team here at Kong, and today we're going to be talking about context. And specifically, we're going to be talking about Model Context Protocol, the emerging standard to connecting AI to basically any kind of enterprise data. And we're not just going to be talking about how to do the connection. We are really going to be talking more about how to survive that kind of connection. As we scale from only 10, 20 tools to 1,000 tools, this is where we start to hit a wall that we usually call the context bloat. And I'm going to show you how to break through that wall using common patterns like the MCP gateway as well as the MCP registry. So let's get started. Now, MCP had different promises for us. If you remember when we were talking about MCP, we start to say, well, it's going to be the standardized way for agents and basically AI to be able to access tools or access different skills and the opportunities to move away from just hearing and listening and generating code to really being able to apply those changes and take action. It's basically the promise was to be able to create this integration layer to the enterprise system so we are able to then connect our AI agents, our intelligence into the systems that are already existing in the enterprise. Now, let's revisit that. So yeah, MCP is brilliant because it standardizes how agents talk to tools, but currently most implementations are just static. So when we have the promise, we hear one tool to rule them all, right? Every single application system that we have in our ecosystem, Slack, Jira, SQL, GitHub, we will have a standardized way to access those, to be able to, consume those services, being able to access them. But the reality, sometimes it's different, right? We are being able to hit that with every single tool that we are adding, with every single line of code, it's just, adding more and more text to our system prompt. There's just adding and embedding the information required by the LLM to be able to process and then select the tool and then being able to execute, ask the agent to execute that tool. So what is the result of this reality? Well, our system prompt really looks more like a legal contract. If you remember those walls and walls of terms and conditions when you sign to a service, well, that's how your prompt looks like when you are sending it over to the LLM after filling it with MCP server tools. And this is what we usually call the context bloat. And this is the problem when we try to scale, when we try to move away from just simple experiments and demos to really enterprise grade systems. Because when we start to talk about, okay, let's gonna be using MCP, let's go start adding services and servers that expose tools, suddenly we find that we are facing too many tools. And when we have too many tools, that means that our prompts are going to be bigger and bigger and bigger. And the problem with that is not that we're just going to be burning tokens, but also we're going to be slowing down the reasoning of our LLMs because it will need to process more information to be able to take simple actions. And also because everything's working through semantic capabilities, that means that if we are not very good generating that context or providing those tool descriptions, we are increasing the risk of hallucinations, of misselection of tools because of what we usually call this overhead for the reasoning. And when you're saying, okay, but I'm just using one MCP server, it has only a few tools. Well, this is a very idealistic MCP architecture. We have one application, one client, my IDE, one agent that it's working with just one MCP server. And then we have some tools that are going to be used by our service. So let's see how this really works in reality. So let's switch to our demo. And this is just a simple application. It's just a simple agent. Yes, I have some MCP servers available, but the agent is just using a very simple prompt, and we are not injecting the MCP servers right now. And the idea of this agent is just basically execute. I'm using Volcano SDK, a TypeScript framework to create agents using JavaScript. So you see the code very familiar. So we're just going to be able to execute this simple agent. So let's go and try to run this this service. If we execute the service, we see the prompt and we see that very quickly, we got the 3 random words. That's the prompt that we are asking this agent. And the good thing about Volcano is that it shows us, how many tools were called, the time that it took to complete, as well as the number of tokens that we are using. And as expected, with this small example, we're just consuming only a few tokens for our application. Now, this is what we were expecting when we were talking about our naive architecture, idealistic architecture. But when we start to add some tools, that's gonna uncomment this, we're just gonna be adding one tool, not any more servers. Sorry, servers, not tools. We're gonna be adding a server that exposes certain amount of tools, and let's see what's going on, what's happening. So let's rerun the exact same service. Now that we have uncommented this, we save it, and then we execute that back again. And this time, again, is the exact same prompt, but we see that the tokens increased to 102 tokens. The latency also increased a little bit. And still we are getting our 3 words that we were requesting as part of the prompt. Now, this simple MCP server that I added had only one single tool, but what happens if we add a couple of more MCP servers? The first one, it's an MCP server that we designed internally, for example, that it's helping me with tools for using GitHub common features. And another that it's going to be accessing Jira and allowing me to access some of the services. So pretty common standard tools that users tend to consume. Again, I'm adding these servers just in case that the prompt requires access to any of those services. However, my prompt still gonna be the same. We're gonna save this again, and then let's re-execute this server, this agent, and wow, we see now that after adding those 2 MCP servers, even though they're not being called at all, there's no calls because the prompt is very simple, we are still sending over to the LLM, or my provider in this case, it's 3,000 tokens. It is a huge increase from the 23 tokens that were used without any tools to 100 tokens used by a server that just had one tool, and then 3,000 tokens with these MCP servers that have more than one single tool. So instead of just using a couple of tokens, we are seeing that this can explode. And imagine that you're sending for every single request all the different tools, so the LLM can choose if they will be using those or not. It will be increasing in a huge number the amount of tokens consumed. So let's get back again to our presentation. So what happened is that usually we have this idealistic architecture, but when we have this reality checked that we just saw in the demo before, every single time that we're adding an MCP server, and we might be adding quite a few, then also the number of tools that are going to be might be imported as part of those servers can explode, on a 10x or 100x kind of growth. And that means that all those tools, all the descriptions of those definitions are going to be embedded in your prompt, are going to be sent over to your LLM. So this put us in a certain risk, and this is why the context bloat and the concept of I'm going to be adding MCP servers just in case really fails when we are trying to scale in an enterprise grade. And this is what we call the hidden taxes of AI performance. The first one that we were mentioning is every single time that I'm adding more tools and more information into my prompt, obviously latency can be perceived. We were having just a second, and we move into 2 seconds. And if we are adding more tools, that information is going to certainly penalize us with the time of response. The second thing that we'll get as part of the additional cost is the physical cost. It's basically how many tokens we are going to be consuming. if you're hosting your services or your LLMs, might be not that impactful. But if you're consuming for a third party, or you're consuming for a vendor that is providing the services, you will see that impact in your bill. And finally, the one that we were mentioning regarding the intelligent tags. When the LLM starts to hallucinate or pick the wrong tool just because it's overwhelmed by the choices, by the amount of information that we are sending over. This is what we call the intelligence task. So what we say is basically agents should receive those tools just in time and not just in case. What it means is that we should be able to take control of how many tools, how much information agents are going to be sending over to the LLMs based on different scenarios. And this is where we want to talk about the MCP gateway architecture and the MCP registry. So what we are seeing now is that we want to have something a little bit more helping us to handle the governance on how we're going to be accessing those services. So you have heard about what we call the LLM router or the LLM gateway, AI gateway that allows us to take control and apply governance and guardrails regarding how we are sending over information to LLMs, basically to avoid our LLM to be misused or to behave in a unwanted way. Now, the MCP gateway covers a similar function. You will try to handle and govern the calls from the agent to the MCP servers that will be then exposing the tools. And this is where we can start apply certain controls and, for example, authentication. And we have authentication, we're able to then define based on the identity of the agent, perhaps what servers are available, as well as what tools those servers can provide to the MCP agent based on that identity. And the third piece on this architecture is the MCP registry. So a registry, as you can imagine, it's a place where we can go and search for MCP servers. So instead of having to add all those MCP servers that we already know statically on the code or as a reference, we can just implement the pattern that allows the agent to query the registry, see if there's a server that it's available that could be useful, and then retrieve the information of that MCP server, and then add it and being able to query the information on that specific server and the tools that are associated. So what we see is that we are moving into this concept of tool selection. We're using the registry and the gateway patterns to be able to handle this kind of flow, where the agent handles the prompt, then it searches for their registry and try to find servers that can be used to fulfill the prompt. And then the MCP gateway, when it receives the request for that specific server, can then filter tools based on the identity or based on certain information, the metadata of the call, to then decide how many tools are going to be sent over back to the agent, so they can be injected in your prompt and then be sent back to the LLM. And then when you have the authorized tools that are available for your specific agent or even for your specific user, and then being able to be consumed. Right, so let's go back to our demo and see how this works in reality. So what we have here is that we're going to see how the MCP gateway works. As we were saying, the MCP gateway handles the communication. So the first thing we did is that we're going to be adding authentication mechanisms for our MCP server. So in this case, I'm going to be showing you how the GitHub one works. And for this, I have already generated a authentication mechanism using JOT tokens. So I'm going to have a JOT token that is going to be showing us all the different tools that we are having available as part of the service. So when we connect to the service and we see the tools that we are being retrieving, they are listed here, right? There are quite a few that allows us to, modify, add, create, delete, basically, the full write and read access to the server. So this is the token for Bob. Bob's a super user and has access to everything. Now, obviously, that means that all this information will go on the request, like the 3,000 tokens that we have seen before. Now, let's imagine that we're going to be using the token for a different user. So let's say that now Alice is the one that is going to be consuming that service. So let's disconnect from the previous version and then try to reconnect now using Alice's token. So let's do a connect. Let's update the token. Let's clear the history and let's connect back again. So this connect. Let's change into Alice. Let's connect back again, and then we can see that the list of tools that now Alice has access, it's being reduced. We're using the same endpoint, we're saying the same process, but the difference is that the authentication mechanism that we're using for our MCP server changed. And now we see that the number of lines have been changed. So let's see how this reflects in our execution. So I'm gonna use now the different tokens. So let's use again the Bob's token. So when we pass the token from Bob and then execute again our agent, again, simple scenario with 3 random words, we see that we're using the 3,000 tokens options. But now let's try to execute this using Alice token. So let's execute that and then now use Alice token with the same prompt. And we now see that the amount of tokens was reduced almost by half just because we are selecting the tools that Alice, that it's not an admin, but it's just a reviewer, can access with the same agent. So at the same agent, I didn't change any code, but the amount of tokens consumed by using the different identity by the MCP server allows us to have an increase of half of the tokens savings of half of the tokens that we were using if we were just receiving all the single tools. So this is one of the ways to try to avoid this context bloat. The second thing that we were mentioning is that we can also have the agent being able to implement the pattern to search information and then being able to select the tool. So let's see how this works. So we have another agent. In this case, this agent, it's connecting to the registry URL, and currently it has some capabilities. So I can ask it to tell me a Chuck Norris joke about history. So what this agent is doing is trying to go search the information and then trying to solve that scenario. The same thing if we try to go and check what's the weather in Tokyo, it will try to get a MCP server and it might not be able to find it because the LLM is not able to have that kind of information, like what is the weather today in Tokyo. And this registry has it's been implemented in this case, in this example, in Connect. It's our MCP registry, where we have different registries where we can then add our servers. In this case, I have a couple of them, depending on if we have some compliance issues, the ones that are hosted by organization, perhaps the ones that we want to share with partners, and the ones for development. Because we want to use some of the development, we will be using this registry, and we see that there's a couple of servers already registered, but there's no one for the weather. So let's try to get into the weather. So what I'm going to be doing is I'm just going to add a weather MCP server that is going to be able to consume and expose tools for the weather. So let's get back to our registry. Let's refresh this. And we see that now there's a weather MCP that allows us to consume and query the information on the weather. Right, so let's go back and then refresh, and let's try to call back again our same prompt and then do again. What's the weather in Tokyo? And for this call, we got the result. We see that the agent was able to find a server on the registry. That's the one that we just created about open weather, and that had a URL. So it used that one to configure and then being able to get the information about the weather in Tokyo. This is a great way to provide tools that are available just in time when the agent really requires them, being able to use this pattern to then improve the capabilities in this agent. I didn't have to change anything on the code side to be able to then send this information and then being able to retrieve and augment the capabilities. I just added the server, make it available through the registry, and the agent was able to find and consume it. So let's go back a bit to our slides and then continue with them. Just to start close out, the idea is that when we are discussing this kind of new architecture, where we are adding these new components on your architecture, your infrastructure, we try to help by removing some of these concerns from the client, from the agent perspective, and put them in the infrastructure. We have been doing this for a long time with other kind of services and parts of our architecture. We can also do this with AI. So the idea is that if we really want to scale on the enterprise side, it's not just having bigger prompts or hacking the prompts. It's really more about the context and how we are accessing them. So it's basically about doing smarter routing. So in this case, we have a scenario where MCP tools going to be going to be increased, and you will have more tools available, and you will be injecting that kind of context and information on your context. So it might not scale when you are adding so many tools. So this is why having semantic capabilities and tools that allows you to take action based on the intents and the content of the prompt can help you to have a better solution and being able to implement your services in a more scalable and resilient way. Okay, I hope you enjoyed the session and you spent a couple of minutes going over these topics. And if you want to learn more, you can certainly reach out to us, being able to ask any questions, and we will be able to try to address them in the comments, or if not, you can always reach out directly. We can certainly start a conversation. So again, thank you very much, and see you in the next time.
Thanks, Hugo. I like the mindset shift from just in case to just in time use of tools. Thanks for that session. We're going to move into the final third of our MCP Academy agenda. It's going to focus a little bit more on scale and identity and authentication, the kinds of things that enterprises need to run MCP in production. And to lead us off in this third is Daniel from Daytona. If you're a developer or a researcher, you might have encountered the need to test untrusted code without affecting your production data and or environment. And Daytona's got a really interesting way of spinning up sandboxes in parallel. And we're talking about at scale, so that you can do just that, so that you can run those kinds of tests without affecting that production environment. So let's learn a little bit more about what Daytona can do and some of the use cases for that capability. Over to Daniel.
Hello, everyone. First, just wanted to thank you all for coming to this meetup. I want to introduce myself. So my name is Daniel. I'm a research engineer at the Perception, Cognition, and Control Lab under Dr. David Wingate from MIT. I'm also a Daytona pacer, and I love going to community events, meeting with new people, And so I'd love to connect after if we have the chance. I have a live demo planned, but before, I just want to explain super brief about what Daytona is if you haven't already tried it out, and just give you a brief overview of the available features and hopefully motivate you to try it out if you already haven't. So, what is Daytona? Daytona is secure and elastic infrastructure for running your AI-generated code. At first, it can sound a bit abstract, but hopefully with the following slides, it'll become more clear what I mean by this. Another few things I love about Daytona is that it's open source with more than 65,000 stars, and we handle more than 2 million sandboxes on a daily basis. Okay, so first I want to talk about why do we need Daytona and what problem does it solve? So as you know, AI agents generate code all the time, and they need to have the ability to run this code. This code is untrusted by default, so it needs to be run in a secure, isolated environment to prevent any potential risks. These environments need to provide speed, isolation, and persistence. And using traditional environments provided by hyperscaler companies isn't a good option for these use cases because they're too slow compared to Daytona and are not purpose-built for AI agents. We need a new infrastructure layer. So what makes Daytona different than the rest? Well, basically, we built the whole stack ourselves from the bottom up. We run on bare metal servers we have built, and we have our own orchestrator. And that's why we're so fast and have a unique feature set, especially for this new generation of AI-driven code. And by fast, I mean lightning fast, where you can spin up a fully functional sandbox in less than 100 milliseconds. For a personal standpoint, my first exposure to Daytona was actually at a hackathon in San Francisco. I wanted to be able to spin up lots of sandboxes and run different AI-generated code very quickly, and Daytona was fortunate to be a sponsor. So I used their SDK, which was very simple to learn, and I was able to spin up 10 to 50 sandboxes very quickly and run the code. And so that was my first exposure to Daytona, and since then, I've always enjoyed building it with it. Another great thing about Daytona is that all of our sandboxes are isolated and secure. Each sandbox operates in its own context, so it doesn't know anything about other sandboxes, and you can basically run anything inside it without compromising on security. Also, Daytona enables massive parallelization, where you can do thousands or millions of sandboxes concurrently, which can be useful for some use cases. Most recently, I think that we hit probably 14,000 sandboxes spun up and ready to go in just under 7 minutes. So if you have the scale, or if you need the scale, we have it. Another great feature is that the sandboxes are stateful by design. So what this means is that project directories, configs, and install dependencies are preserved during the whole sandbox lifestyle. So from a personal standpoint, as a research engineer, this is great for doing a lot of parallel rollouts. I can have my reinforcement learning environments for coding agents duplicated across thousands of Daytona sandboxes to get independent trajectories very quickly. Sandboxes can also be customized by defining snapshots. So snapshots are just custom reusable templates which are used during the sandbox creation. So when created, Sandbox will contain everything specified inside that snapshot definition, your dependencies, settings, resources, and this can help speed up the process. We have multiple physical locations where we host our infrastructure, so anywhere you're at, it's accessible. We have regions in the States and in the EU and soon in Asia, and then hopefully we'll expand to India, Africa, South America, really just depending on customer requirements. As I said previously, Daytona is purpose-built for AI agents, and this is really seen in our SDK, which essentially gives your agents a computer that they can use for whatever purpose they need. So currently we provide a software development kit for Python, TypeScript, and Go. And on the radar, we're hoping to expand towards Ruby, Java, Rust, and Elixir, depending on what people need. We also have an MCP server, which you can use either by integrating directly into your LLM provider or using it as a tool for your agents. Another way to do this is that if you have a language that isn't currently supported by our SDK, you can still generate the API client from our OpenAI specs and consume all Daytona features so that you're also covered. I just want to show you a quick code example from our SDK. So here we see an example of a shell command execution with Daytona. It's basically one line, and in the response, you can query the exit code, standard output or access artifacts like charts if your command generated them. In some cases, you need to be able to run one or more long-running commands which need to share same configuration and environment variables. This can be accomplished through sessions. You can stream logs for these long-running commands in real time, which is super useful for tracking progress, debugging, or giving feedback to your end user. Another great thing is our file system toolbox. It makes it very easy to manipulate files in the Sandbox file system. Another thing that we also have is a Git toolbox, which provides you with Git operations like cloning, committing, and pushing. For me, this was useful when dealing with private repositories, which require token access, and it's critical to prevent this token from leaking outside the sandbox. And so the logic is implemented inside our toolbox method, so you don't need to bother. You can also expose processes on any ports inside the sandbox by generating the preview URL, and you can inspect them inside the browser or by doing a curl command to get the URL. Recently, we also have PTY support, which you can use to execute interactive commands that require user input or some other type of interaction with the terminal. Another thing is that there's sandbox volumes. This is a feature which enables you to create volumes with pre-populated data sets that can be later securely shared and accessed by one or multiple sandboxes. Again, this speeds up time for quick spin-ups and allows us to do what we do at a very fast level. Also, there is our computer use feature, which enables you to run desktop apps inside the sandbox and then interact with the graphical user interface of these apps with your agent. For debugging and inspection purposes, you can either SSH directly inside the sandbox or can use our web terminal feature, which enables you to have a fully functional terminal inside the browser. Daytona also provides a first-class Docker support in ways that you can count on. You can create sandboxes, snapshots directly from Docker files, or you can use our declarative build API. Also, we have Docker in Docker support, meaning you could run Docker containers inside the sandbox or use Docker Compose to set up an environment. And again, I've covered a lot of different use cases, but I just want to share with you guys what are people building with Daytona. Some of our customers include reinforcement learning, like I mentioned before, coding agents as well, data analysis, data visualization. And what I want to talk more about is AI evaluations, because this was another opportunity I had. At my first internship in San Francisco, I was on the ML team and I was doing evaluations. When a new model would launch from Claude or OpenAI, it was pretty important that we got a benchmark for this model to see how it performed. And for these coding tasks, I would always use Daytona. It made spinning up the sandboxes that are isolated and secure very easily, and it naturally fit into our pipeline. This allowed us to get results from these state-of-the-art models very quickly, update our own internal dashboards, and see which models did good at what. So that is one use case that I'm very familiar with AI evaluations. I think the best way to get started with Daytona is simply to just start building something. It's a super fun time to build, and a lot of you guys have great ideas for what you want to build, and building with Daytona is easier than ever. You can check out the documentation where it's actively maintained, and it's very easy for other LLMs to parse and understand the documentation to help your idea come to life. Here you'll find deeper explanations of all the features, examples, guides, and best practices, so you can quickly get up started and get your project running. Last thing I want to do is kind of set a plug to the Slack channel. I really encourage you guys to join the Slack community to see what everyone's building. It's very active, and if you need help or have any technical issues, you can definitely reach out there and get help very quickly. So I'll leave this up for about 5 to 10 seconds just so you guys can scan the QR code. Okay, and now moving on, I'm excited to show you guys the demo that I prepared for this. So here's what I call it. It's a SQL agent competition. So let's say you have a rideshare company based in New York or San Francisco, and you want to interact with the data. So usually we'll have a lot of different AI agents, and that can do it in your terminal, or maybe you have a simple web app to access and visualize this data. With all this AI generated code, you do want to be careful because at times, what if your table gets dropped? What if all your databases get deleted? That would not be very good for a real production product. So for this demo, I have an agent competition where I'll spin up 6 different Daytona sandboxes with a snapshot of my internal data for this rideshare company. This way, that each sandbox is isolated, so no real production database is touched, and I still get the information that I need at lightning fast. And so here we have the query. I'm just going to say find the top 10 customers by total spend in the last 90 days. Pretty simple query, but also very easy for an agent to mess up. And so I have different prompt templates for how I want the agent to approach. And let's see how it goes. So when I click run, it'll be very quickly. So you'll see that these different panels will pop up with the sandbox and the different agent within them. So let's do less talking and we'll see how it goes. I'm going to click run. Here you can already see that they're booting the sandboxes. We have a query planner, a performance hacker, safety cop, narrator, regression tester, and a chaos agent. With this demo, you can go and click on these cards and see what was the code that the agent created. Here we go. We have latency at 3.3 milliseconds, and here's the generated SQL code. Okay, we can go to our performance hacker. I noticed that the difference that we see an improvement in latency, 1.6 milliseconds here for our performance hacker, because we wanted the best performance for this. Here we see a pretty simple SQL query. Also, we have safety cop. This one, I think we're emphasizing safety. We don't want any database to be destroyed and customer data to be protected. Then we have other versions like regression tester and narrator, which is very human readable. I also included one on purpose called the chaos agent. The chaos agent, I wanted it to deliberately do something wrong in the database to show you that with Daytona, this isn't a problem. Because it's run in an isolated sandbox, if the chaos agent goes wild and tries to delete your database, it's isolated to that sandbox only, and your production database is not touched. This is really the new meta for AI generated code where you're not risking safety for speed. And here we can see our winner. It's the performance hacker. It also gave a description of why it won. And what you just saw wasn't just 5 to 6 different API calls to Claude or OpenAI. This was 6 different CPU environments spun up in under 2 milliseconds. Code ran in them and outputs given to us at a lightning fast speed, all under fractions of a cent for API costs. And so I hope this kind of gets you excited about building. If you're a student, you can mess around with Daytona and build different projects here and there and do a lot of learning. These CPU environments are a great learning experience. If you're a builder and you want to move fast, you can use Daytona to have these CPU isolated sandboxes so that you're not risking safety. If you're a researcher like me, you can use these for a variety of different things so that you're not CPU bound. But again, I hope you guys enjoyed the demo, and yeah, I'd love to connect with you guys up after this. And if you're building, I hope you guys build with Daytona.
Thanks, Daniel. Yeah, when that chaos agent goes rogue, you want to make sure that it doesn't touch your production database. Thanks for the session. Thanks for the demonstration. Next up is Greg, who's the CTO at Manitou. Greg's going to talk about identity and authentication. He's got a really neat demo himself. He's going to show you why OAuth alone isn't enough and how to make sure that when you've got different personas in your organization, they have different entitlements on the other side of that MCP server. So I'm going to hand things over to Greg at Manitou now.
We're witnessing an explosion in AI adoption, and model context protocol is helping to standardize how agents connect to the outside world. A key question remains, though, how do we secure them so that we can deploy confidently? Today, I'm going to talk to you about what we see as a core unaddressed problem in MCP, which is governance and observability. My name's Greg. I'm the CTO and co-founder of Manitou. Manitou's in the business of providing governance and knowledge protection solutions. To start, I want to ground us in what we mean by governance and observability in AI agents. As we see it, there are 5 principles at work here. The first is containment. Think sandboxing. So what we want is an environment where the agent cannot reach outside except through gates that we control. The second is isolation. This means removing any non-essential resources from direct agent control or memory. things like local files, credentials, key material, etc. The agent shouldn't be holding these. We're going to broker them on their behalf. The third is cohesion. For governance to work across distributed systems, every user, system, and resource needs a universal identifier. This will enable us to correlate requests and data across the system. The fourth is permissioning. That's where we define the access control rules, the who, what, when, where, and why. The last is observability. We need to clearly see what's happening across all of these distributed systems, both in real time and after the fact. The key observation is that MCP is a primary path an agent uses to reach outside containment. That makes it an integral component for any governance and observability strategy. So why does MCP need governance and observability? From our perspective, we think MCP already has a solid foundation. For instance, it provides first-class support for OAuth, but OAuth does not provide a full solution. It only addresses authentication and basic endpoint authorization. It doesn't address the application layer at all. So once an agent's authenticated at the front door, what it's allowed to do with each tool is left entirely to the tool itself. This matters because every tool an MCP server exposes presents its own unique risks. The surface area grows with every tool added. With the observation that agents are unpredictable, one problem is that you can't enumerate every combination of inputs an agent might send. There's also a bigger identity problem. Agents are often acting on behalf of someone else, a user or system, etc. The immediate caller identity will be the agent, and this alone doesn't tell you enough. You often need the full context of the delegation chain behind the request. The conclusion is straightforward. Any shared MCP endpoint that exposes tools needs granular authorization and real visibility into what's happening. Ultimately, authentication gets you in the door, governance determines what you're allowed to do once inside, and observability lets you confirm that the governance is working. There are various ways to implement access control rules, for instance, role-based and attribute-based or policy-based, etc. We're big believers in policy-based access control. Policy-based systems allow you to embed your domain expertise and requirements directly into the flow. So it's your identities, your resource properties, and the context that matters to your business. They're all factored into the rules that you define, and the system executes them at scale. What we're looking for is precise, granular control over outcomes. Requests that are granted or denied by design, responses custom tailored to the requester's entitlements, etc., on a case-by-case basis. Control is important, but also ensuring that the system remains observable, understandable, and verifiable is equally so. The ability to replay recorded decisions against historical or proposed updates to the policies becomes an asset of verifiable behavior. I put together a demo to see this all in action. I'm going to leverage GitHub as my example, since most of you should be familiar with it. Note, however, that the same principles could apply to any MCP service. To start, we're taking an unmodified GitHub MCP from the public repository and a simple MCP-enabled LangGraph-based agent that uses the Anthropic API. We're going to run the GitHub MCP and chatbot within our own infrastructure, which happens to be Kubernetes in this case, but we're going to do so in a way that applies the principles we've been discussing. For the MCP service, we will leverage ToolHive to seamlessly infuse GitHub MCP with authentication and authorization. We will apply similar protections to our agent using AgentVisor. In doing so, we are applying a unified namespace of identities and policies to govern our system, despite its distributed and decoupled nature. Identities are defined in Keycloak as an OIDC OAuth provider, and policy and observability are managed by the Manitou policy engine. We're going to introduce 3 personas, each with distinct entitlements to leverage the shared infrastructure, but with experiences that will match what we want, not what the LLM or MCP service decide. The main takeaway here is that we're taking an MCP service built on a very coarse concept of identity and a complete lack of tool-level authorization, and applying the concepts of governance and observability. One agent, one MCP server, custom outcomes. The demo uses 3 personas, each representing a different level of access. Avery is assigned the role of reviewer. Avery can read the repository but can't make any changes. Blake is assigned the role of reporter. In addition to being able to read the repository, Blake can manage GitHub issues. Cameron is an external contractor. Cameron is not on the same team as Avery and Blake and has no access to the repository. Any attempt by Cameron to access repository data will be denied. What you're seeing on the screen now are 3 web browsers that are pointed to our chat agent, and we're going to log in with the 3 personas that I just talked about. So on the far left here is our user Avery. I'll log Avery in through Keycloak. Same with Blake. And same with Cameron. So once again, all three users are using the exact same instance of agent and MCP server, but they should all have a different experience that's customized to their entitlements. I'm going to ask the agent with the same prompt for all three and see what the difference in the response is. So in this case, I'll just ask, what tools does the agent see? So the agent's now processing the request, and it's going to factor in the exact entitlements of each user, and we can look at the response that was generated and kind of see the differences between them. Now Cameron's going to be the most obvious because Cameron has no access to MCP at all. So if you look on the far right, representing Cameron's session, the answer to the prompt of what tools do you have available is, I currently don't have any tools. And we'll look at what that means in a moment when we review the policy decision log. But let's focus now for the moment on the other two users, Avery and Blake. Their responses actually look fairly similar. If you recall, Avery is a read-only reviewer of the repository, while Blake has the additional ability to create issues. So if we were to really dig in and look closely at what the response to this prompt was, we can see on Blake's side here that we're including the ability to create issues as the available tools, whereas on Avery's, we'd see no such option. They're only read-only. And that will be reflected in basically what they're allowed to do as well. So what I think I have at the moment is a situation where we have no issues created. So I can confirm that. So the first thing I'll do is ask on the Blake persona, what open issues exist in my test repository here, which I set up for this demo. And I believe the answer is going to be there's no open issues. So there are no open issues. So I'm going to have Blake actually create an issue, which he is entitled to do. So I'll say create a new issue titled demo test with the body testing 1, 2, 3. And while that's running, I'm going to queue up Avery over here to say, what open issues do you see So we can see here from Blake's session that it successfully created the issue. It says issue number 6, and I would expect Avery to be able to see that issue given that she has read-only access. So there it is, issue number 6. Now Avery, maybe not realizing what her limitations are, maybe tries to close that issue. So we'll say close issue number 6. And this should be denied because Avery does not have write access to the repository. Says, I'm sorry, I don't have the ability to close issues. We tried the same prompt over here in Blake. Close issue number 6, and we should see that successful. There it is, successfully closed. So now that we've seen the behavior from the user's perspective, let's actually take a little quick look at the observability data and confirm what we're seeing is what we expect. So what we're looking at now is the observability dashboard for the policy engine. This is giving us a bird's eye view of the system. Right now we can see that in our index there was 154 decisions recorded. This was built for arbitrary scale, so there could be millions or billions of these decisions, and this will help you to visualize what's happening in your system. In this case, we're going to take a look at the decision log, and if we look casually through the data here, we should see the different interactions of our users, such as Blake and Avery, as they interacted with the system. So let's take a quick look at Cameron to start. So if we look specifically at Cameron and look at the records that Cameron generated, we have a very simple view here, right? So what we see, starting with the oldest record, is that Cameron was interacting with our agent, which is what we expected. He created a new conversation thread. He created a new run within that thread. That was our initial prompt asking what tools were available. What we see happen next, if we focus in on the details here, is that the agent made a down call to request the tools that were available. And in this case, Cameron was not blocked from doing that, which was expected because we placed our policy actually at the tool hive side, right? So Agent Advisor was permitting Cameron to make a request to list tools, but the tool hive implementation of the GitHub MCP was not. That's where we placed our policy. So in this case, we can see that one was blocked. And we know this is an example of an ingress filter denying the request. So from Cameron's agent perspective, the response is there are no tools available, which is exactly what we saw the LLM respond with. So in this case, the conversation was cut fairly short. There were no tools. It responded that there were no tools available, and that was the end of the story. Let's now look at a more interesting use case, which is our user Avery. Now Avery, as we know, had a little bit more access than Cameron. So if we go back here to the beginning of time, with Avery, we can see there was 66 total records created for Avery's session. Again, starting at the very beginning, creating a new thread, a new conversation thread, creating a new run, and the agent proceeded exactly the same as Cameron. However, this time, when we see the down call happening to list the tools, the tool list was allowed, right? So in this case, the request was received at the MCP server. The policy for that particular user was allowed to make a tool list. And let's actually take a look at what happened there. So if we click on this record, we can see overall that this access was, let me make this a little bit bigger. This access was granted, as we just said, and we can look at the details of why it was granted. In this case, our user is carrying policies for reviewer, as a role as a reviewer, and a resource that is fairly permissive. If we want to review the details, we could say, click on this reviewer policy and get the playback. So what this is doing is taking the inputs that were given to the system at that time and replaying them through the policy engine and telling us exactly line by line which lines of the policy affected the outcome. In this case, the policy was granting the access, which is what we expected because Avery should have some access to the tools. So let's go take another look at some of the other details in her situation. So the tool list request is an ingress request where we're asking the system to execute this verb. And these tool read operations are the egress response of the data. So in this case, some of these tools are being blocked and some of them are not. So in Avery's case, she's allowed to see any read-only operation. So anything that's a non-read-only is getting filtered out. That's why you see these denies. And anything that's read-only is allowed through. So this represents kind of a customized response for Avery. The LLM is only seeing the tools that are accessible to Avery and is now presenting them as an option. And then further interactions are, as we chatted back and forth with the agent, what's going on here. Now, we don't see any further rejection here because the LLM was not even presented with the tools that could change the GitHub instance. So it wasn't like it tried to make a call that it wasn't allowed to do. It just doesn't see those tools. So from Avery's LLM perspective, it doesn't have those options, which is exactly what we saw in the response. So this basically was pre-filtered out by not even giving her the option to call those tools. Now, had the list presented all these tools, even if she didn't have access to them, that would still be okay, because if the agent had tried to invoke one of those verbs that she doesn't have access to on her behalf, it would have been blocked at that level, right? So in this case, we just pre-filtered them out, but it would also work from a post-filtering perspective. And just to conclude, we'll take a quick look at our most permissive user here, Blake. That user should have a richer experience and fewer restrictions. So again, we start with our thread conversations being initialized, running through to look at the different tools. In this case, a few more tools are being added. So add issue comment, for instance, wasn't filtered out, and anything else related to the issue should be in the list as well. And then, further interactions were Blake interacting with the system to update GitHub, in this case, to open and close those issues. And that concludes the demonstration for today. I have some links here if you're interested in following up and learning more. Thank you very much for your time.
Right on. Thank you, Greg. I like that. Nice and simple. 3 different personas, all using the same agent, the same MCP server, but having very different experiences. It's a very relevant example for what enterprises are dealing with on the daily right now. Okay, our final session for MCP Academy comes from one of the engines behind today's event, and that's Databricks. Elise from Databricks is going to show us how to use a Unity catalog to discover and secure both first-party and custom MCP servers. And then this session also includes a snappy demo on how to turn an OpenAPI spec into a governed MCP server in minutes. So I'm going to hand things off to Elise, and then we'll wrap up for the day. Thanks.
Hey everyone, my name's Elise Gonzalez, and I'm a product manager here with Databricks on our agent platform called Bricks. I'm really excited to talk to you today about building governed production AI with MCP on Databricks. If you aren't familiar, Databricks is the data intelligence platform. We started out by inventing Spark and being a platform where people could run Spark at scale, but we've now really grown into a number of different areas, including data warehousing and our agent and AI platform, so that people can use their governed data on Databricks to build production-grade AI. For our agenda, what we'll cover today is we'll start by talking about the governance challenge, which is really one of the biggest challenges that enterprises face when they're looking to put AI into production. We'll then talk about what Databricks offers, and then finally we'll talk about how to leverage MCP in agentic workflows and a demo of that in Databricks. When we think about the agent governance challenge, we really think about a number of components here. So we've really prided ourselves on providing a platform for data governance for many, many enterprises across the world, where they can put all of their data, make sure it's secure, make sure the right people have access to it. But how do you start to do that as well when you start to think about agents and all of the components that agents need to leverage? We're really finding 3 key challenges here. The first is that MCP servers are the new thing that everyone wants, but we are finding teams are duplicating efforts. And so that means that there may be 2 teams who are actually building the same set of tools, the same set of MCP servers. And so they're repeating work and they're not finding this sort of shareability and discoverability across their company. The second challenge here is that teams build MCP servers, but they don't have any common auth, they don't have any centralized permissions. And so this can inadvertently open your company up to not following your security policies, and can be a really big challenge when you're actually trying to build MCP and build agents, is how do you actually follow, what auth model do you follow, and what permissions do you use? The final piece is that MCP servers are often gateways to extremely sensitive information. And so we are finding there are a number of companies that are reticent to deploy them because they aren't sure how to secure them, how to make sure they're following all of their best practices. And so this is really where we want to help, and where we've been able to have customers be able to start using MCP in production is by providing a governed, centralized platform for discovery, but also for solving permissions, authentication, all of those things. And so this does really create some risks. And so if you have scattered MCP servers or sort of all across the enterprise, there's not really a central repository of them. You have a number of mixed identities in here. That could mean you have exposed data assets and you have unchecked permissions. And so all of this is really a nightmare to enterprises that are looking to deploy agents and really have their workforce start to use them and start to use AI at scale, is they need to be able to solve all of these together. And so all of this creates ungoverned flow of data. And so ultimately that's what we're looking to solve and what we're helping a number of companies all across the world solve today. And so all of this starts with our Unity catalog. Unity catalog is a single governance solution for data and AI assets on the Lakehouse. So not only do we govern tables and I would say traditional data, we can also govern MCP servers, we can govern models, we can also govern things like skills and agents. And so this gives you unified visibility into data and AI, a single permission model for data and AI, and also still enables open sharing. So Unity Catalog is open source, and we do also have Delta sharing and other components that people can use to share these across their organization. And so we have a number of pieces here that support MCP behind Unity Catalog. And so you can build managed MCP servers for UC tools, vector search, or Genie rooms. So these are all servers that we provide out of the box once you've built these on Databricks. You can also host custom MCP servers through our Databricks apps product. And then you can register external MCP servers in Unity Catalog and install them from our marketplace that hosts MCP servers as well. So this really gives you broad discoverability of all of these servers, as well as the ability to govern who has access to them and ensure that your permissions are maintained throughout. What I'll start by talking about here is our first-party MCP servers for Unity Catalog data. So we have a number of different managed or first-party servers that we offer out of the box for our customers. And all of these have on behalf of user auth enforced out of the box. So any permissions that you put in Unity Catalog, we can continue to maintain. We have Genie, which is our natural language SQL agent. And so this lets you build text-to-SQL agents that can operate over your data and answer questions for your users. We also have vector search, and so this is for querying unstructured data for document retrieval at high scale. We have UC functions, which are really known queries or tools inside of Databricks, provides access to data quickly. And then we also have an MCP server for our DB-SQL product, which is really great for testing SQL queries and for development inside of an IDE. All of this then comes together in our MCP catalog. So you're able to both host and leverage external MCP servers, host custom ones with our apps product, or leverage any of our first-party MCP servers and see them all in one place. So this lets you really standardize tools and govern and deploy them. So it provides that discoverability surface so your users can actually see all of the tools and servers that are available to them. Still provides governance at a number of different layers. Again, we maintain on behalf of user auth for you, but we can also pass that through to a third party, which I'll show you an example of later. We also perform authorization, so platform admins want to log which users have done what. They also want to maintain those permissions throughout. And then you can also organize them and make sure that as they're in their catalog, you actually have that natural sort of grouping mechanism. And so when we think about our MCP architecture here, there are a number of different components. So we do actually have a Databricks managed MCP proxy here in the middle. And this is what all of our MCP servers connect through. So all of the first-party managed ones that I just mentioned, as well as any external servers. So we're able to proxy that connection to either that third party or to our own first party servers. And then you can actually leverage them inside of Databricks. So if you're building agents inside, or externally as well. So if you wanted to leverage one inside of an IDE or you're building agents elsewhere, you can still use this as your MCP backbone. Finally, the last thing I'll talk about here is we do have MCP in our Databricks marketplace. And so this lets you share MCP servers and unlock AI use cases. And so we have a number of different providers that have listed their servers in our marketplace, which I'll actually show you a demo of here in a second. So I'm going to start by jumping into the Databricks product here. If you haven't seen it before, this is our workspace. So I'm going to start by going down here to our Agents tab. That's where you'll find both agents and MCP servers. And so right here, I can see all of the MCP servers that are available to me. So this is my MCP catalog. I can also see a number of different marketplace providers. So this is just a short selection of some of them that we have available. But if I did hit see more here, I could also see all of the listings that we have. And so this makes it really easy to install them, to make sure it's actually from the person that you think it is, and really makes that setup really easy. I can also see all of the ones that I have provided to me. So again, I have external ones, I have custom MCP servers that I'm hosting, and then I have the 4 that Databricks provides for you out of the box. And so if I did want to test one of these, so let's say I wanted to look at all of my Genie spaces, I can see that there are a number of these created both by me and by others in my organization. If I were to click on one of these, I can actually see the tools that are offered to me. So you can see, again, we're proxying that connection for you. You just have to copy that URL and then log in, and you can start to use it. And then here are my tools. So this is all provided out of the box for me. So I didn't have to set any of this up. And so this also pulls in the description from my Genie space to give the LLM more context as it's using this MCP server. So let's hit try in Playground. And so jump in. And so I can see here that I have my Finance Genie space in here. And since I did create this one, I know how to ask a question of it. So what is the performance of all my candies? So this is my fake AI candy company. And so I have a number of different candies that I'm offering. And so this has my finance and P&L information. And so you can see it's issued that query to that Genie space. It's thinking. And so we'll get an answer here in a second. And so the query is still processing. And so it's able to then use that pull response tool that I showed you. And so we can start to pull that response. We can see the conversation ID, and then we can actually see it came back with a select statement. So it actually gave me that text to SQL answer, came back with a bunch of information. I can see all of this sort of nitty gritty details, but then I can also see this overview here where I can see all of the different candies that I offer, as well as their cases sold, net sales, etc. So it's able to just pick up those tools naturally right out of the box. So now going back, I'm going to talk next about hosting custom MCP servers with Databricks apps and how easy this is actually to get stood up. So just like I showed you before, our overall MCP architecture, if you are using a custom MCP server, again, you can use that with our agent platform. So if you wanted to build and deploy on Databricks, you can do that. You can also use any MCP server inside of another app, so you can start to build them together. But you can also connect them externally. So if you do want to use them inside of an IDE, you absolutely still can do that. What's really nice here is that you can securely host these and get built-in authentication, built-in permissions, and again, that governance model all for you. And so we do have a number of companies where maybe they don't already have OAuth built into their service. And so they are using this to be able to really bootstrap that OAuth sort of backbone for them while still calling their own internal APIs, all through the security of the Databricks platform. We also can take an open API spec and actually turn that into an MCP server for you super easily. So I'm actually going to do that for you next. So what I'm going to do is the weather.gov API is open, really easy to use. So you can see that it has a number of APIs in here. I also have the open API spec. And so that's actually all you need to get started. And so I've gone ahead and uploaded that into Databricks here. So just into my catalog, into a volume. So I can see I have my spec.json, and I can see that I have weather.gov API. And so that's really all I need to get started when I want to host an MCP server with Databricks. And so all I need to do is go here into Databricks under Compute and Apps. And if I hit Create App, we have a number of templates provided out of the box for you. And so under agents, I have a number of options in here. And so I can just start with a Hello World MCP server to show me how to use it, or I can do an open API spec. And if I am to do that, all I need to do is select that volume that I had where I uploaded my spec.json. All I can do is hit next, and then it'll actually just install it for me. Luckily, I actually did this right before we got started here, just to sort of expedite my demo here. So you can see I have my MCP server weather spec, it's running. And so what I can do is jump into our playground experience. So just like I showed you before, I have my MCP server weather spec here selected. So then I can say list the tools. And so it'll reach out to my brand new app here, and it'll start to actually list all of the API endpoints. So I can see alerts, I can see active alerts, active types of alerts. And so there are a number of different APIs available to me, all just because I uploaded that API spec in here. So made it super, super easy to get started with MCP, still governed and backed by OAuth and all of the permissions in your organization. So the last thing I'm going to talk about is connecting MCP to agentic workflows and our ability to actually reach out and proxy that connection for external MCP servers as well. So what we are finding is that enterprises are still facing a critical challenge is as they're enabling AI agents to securely interact with private data at scale.
That's fine.
And so they really want to be able to bridge that gap between powerful AI agents, but still maintaining security governance at the scale that they're looking to operate at. And so this is really where Databricks comes into play. So we're able to have an orchestration agent that combines all of your data, your LLM, your tools, and your skills, and then your MCP server. And so it can run on behalf of the user, but it can as well run on its own agent identity. So it's really flexible to your specific use case here. And so in the next example I'm going to show you is I'm going to jump back into our playground experience. And so from our catalog, I've gone ahead and chosen, I have a GitHub MCP server here, and then I actually have another tool. I have my Python executor tool. And so the first thing I'm going to ask is, who am I? So I'm going to check who am I logged in as on GitHub. I want to make sure it's my identity because I'm going to be making some changes to a repo I have here. And so you can see it's actually logged in as me. And so we are proxying that connection. And so I'm able to do some lightweight prototyping actually directly in our playground experience, still backed by Unity Catalog. And so what I'm going to ask here is I'm going to ask, in my Python calculator repo, I don't have an add function. Can you create one for me with the Python tool and then create a PR for it? So what it's going to do is using that built-in Unity Catalog function we have for Python executors, as well as that GitHub connection where it's actually logged in as me, it's going to reach out. It's going to look at that Python calculator repo that we have available, start to read it and get file contents. And then it's going to use, again, that built-in Python executor still inside of a sandbox, test that out, make sure that the code works. And then it'll actually then create a PR for me here in a second. So once it's done thinking, amazing. So it's testing the add function. So it actually tested a number of combinations, just basic addition, as well as some decimals and some negative numbers to make sure it got everything correct. It's also listing the branches. So there are a couple of branches open, and then it's going to create another branch for me, and then create or update file, and then create a pull request. And so we can actually look here. And so it created the third pull request here in my repo. Let's actually open that up and look, make sure. Amazing. Okay, so we can see this was created as me. So again, I was logged in through that connection. And then I can see the files change. So I can see it added a quick add here, and then it just slotted it really nicely into this file. And so if I wanted to review this, I could. But again, this shows you that it's really quick to start prototyping. And then I could even start to get code. I could export it to a Databricks app and start to build my agent that way after I've already been able to prototype everything and make sure all my permissions work. So this really shows you the full breadth of the Databricks platform and how we are enabling you to build with MCP at scale, still with governance in mind, and still get that speed that agents have promised to us. So I want to say thank you. Thank you for taking all the time today. I hope that you learned something new about Databricks and the Databricks platform. If you want to learn more, there's a tiny URL here to take you to our doc site to get started. So thank you very much.
Thank you. Thanks so much, Elise, for showing us how easy it is to host custom servers or pull verified servers from the Databricks marketplace. We really appreciate that. And of course, thank you to Databricks for getting behind today's event and for being a champion for MCP Academy. We're grateful for the support. Thank you to Founders Bay and to Marianne Becker for making sure that this event was available to that community. It was great to see a bunch of you register en masse for the MCP Academy event. Thanks to the Stacklok team for their support and making sure that we had a great speaker lineup today. If you have questions about MCP, just given how fast this landscape is changing, you can reach out to hello@stacklok.com anytime. We're happy to take your questions and see how we can be there for you in your MCP journey. And with that, we're a wrap. We'll be publishing recordings from today's sessions on our YouTube channel. We'll make sure that everyone who registered for the event has access to those recordings. And again, we really appreciate you joining us. Thank you so much for attending MCP Academy's virtual event today. Bye for now.